All right. Hello. Hello. What day is it? It doesn't matter what day it is. This is stream number 10. Got made it to maybe to double digits for already stumbling to even speak properly. But yeah, number 10 of this thing of me trying to implement a WebAssembly interpreter in Ruby. Um, the story so far, I'm doing this to have fun more than anything else. Secondary goals are to demystify WebAssembly a bit, which I don't really know anything about, and also to just sort of work in the open, share how I do it, for whatever that's worth. Some principles I want to remind myself of as I work on this. Because I'm doing this for fun, it's more important that it's fun than that it necessarily works properly. So I'm not going to allow the desire to get a working WebAssembly interpreter to sort of dominate the need to just enjoy myself. I want the code to be correct. I'm sort of realizing as I'm working on this that it's sort of what I'm trying to do is sort of write a principled implementation. So I'm trying to, rather than looking for stuff that's the most performant or the cleverest, I'm just trying to find a way to make sure that everything is done right. So yeah, focusing on correctness, focusing on clarity more than cleverness. I'm not trying to do software engineering here. I'm just trying to put something together that is explicable, even if it's not the most well-designed code. I'm trying to do it all in pure Ruby. I think that's going okay so far. I've done quite a lot of work to keep it in pure Ruby rather than just dropping down to C and using, native floating point numbers. So that's been interesting, and also trying to do it without dependencies. And again, there are some third-party dependencies that would have been helpful up until this point, as I have now subsequently discovered. But I'm enjoying just writing all of the code myself and trying to make it all work. So that's the deal. Brief retro on what happened last time before I get momentum up and start working on this session. Still going on the old floating point numbers. Like I said, this is the 10th stream I've done, and this will be the 6th stream that I'll be working on floats. So I'm almost done, I hope. I looked at the bitwise and the comparison operation tests that are outstanding for floats, and the good news is that there aren't many actual instructions that I need to implement. There's just a large number of tests for them. But in terms of implementation, I'm not expecting it to be too onerous. So that's good. It is time to move on from floats, I think. Like, I wasn't expecting it to be such a slog. This project is supposed to be about WebAssembly, not about IEEE 754. So I'm starting to feel a desire to put floats to bed. So I'm hoping that in this stream, I'd be really happy if I could get f32.wast, f32bitwise.wast, and f32 whatever it is comparison.wast. If I could get all of those passing. Oh, and there's float expras as well. But really, I just want to get those f32 *.wast files working. And also, I'm hoping that I can just run the f64 versions of those and they will just work. We'll find out, but that's my hope. I've spent quite a lot of time doing refactoring, and the code is way less messy than it was, which I'm really happy about. But powering through those last few F32 instructions did add a lot of duplication to the code, and there already was quite a lot of duplication in the interpreter from the integer operation. So I'm just kind of recreating the same duplication that I had in the integer operations, and I think I can tolerate quite a lot of duplication. I don't think it's de facto bad, but I think it's sort of tipped over into being unhelpful for clarity. So I think now I would like to spend a bit of time sorting that out and making some sort of organizational decisions about how to deal with that duplication before I charge into the bitwise and the comparison operations. And finally, when I reflected on it, I realized that it's increasingly starting to get to me how crappy my test runner is. it's just a shell script, but it's becoming increasingly painful. The tests are getting slower and slower, and so as it takes longer to run, I'm finding it more painful, and like the failures in the test are becoming more subtle and more obscure, and it's like getting harder to spot them in the sort of in the mess of the output of the test runner. So if possible, maybe this is a stretch goal, but I would like to spend a bit of time making the output of that test runner nicer, like maybe add some antsy color to it so that it's green or red if the tests have passed or failed. Like even the kind of cognitive overhead of reading a screen of undifferentiated white text to try and understand whether the tests are passing or not is actually starting to stress my brain a bit. So at some point I want to try and make the test runner a bit more pleasant to use. Developer experience is very important. That's the wrong button. I'm a developer. I want to have an experience of working on working on a WebAssembly interpreter. So let's do that. I think where we got to is that all of the tests are passing, and then we've got a pending one on the end. So yeah, I've got this pending block in the test script. So this is trying to invoke an operation called copy sign, which I haven't looked at yet. So all of the F32 stuff is passing. F32.wast stuff is passing. Let me bring up a browser. Where do we want to go? GitHub WebAssembly spec. So I think I'm going to do a little bit of deduplicating my existing code before I charge into this, like I said in the retro. But just as a preview of what I'm going to do, I think it's F32. Oh yeah, I think last time. Oh yeah, it was Bitwise that I added to this test script because this one was significantly shorter than the comparison one. You can see there's actually only 3 operations in here, so that really shouldn't be difficult at all. Let's have a look at the other guy. Yeah, so again, this one's only 6 operations. So we're pretty close to being done, actually. This is with implementing floating point numbers. So it's not going to be too bad. However, I did want to, well, as always, I put a few more to-dos in here. I mean, there's still a bunch of to-dos from before. So I added some things like, yeah, I could colorize the test runner, reduce the noise in the test script runner thing. Oh yeah, one of the things that was annoying me about the test runner is that if I run it again, you can see it like spends a long time parsing the S expression in some cases. So I mean, it's really not that long, but it feels like a long time when I'm running it a lot. There's not really any reason for it to pause for ages. It could just incrementally parse the input, and it could be handing control back and forth to the interpreter, and that's because Ruby's good and has got fibers and stuff. It's really easy to do that sort of coroutine style thing where you're just handing control flow back and forth between 2 bits of code and just using a numerator for that. So that should be quite easy. So I'd quite like to do that at some point. Oh yeah, this is just pedantry. Oh yeah, there's some more recent stuff I put in here about, again, I just read through the code. I was like, there's lots of operations in here that are very similar. Well, let's have a look. I mean, I think this is what I want to look at first. It's this sort of duplication of the float arithmetic operations that bothers me the most. So I might start with that. A couple of niggly things here about, like, there's a lot of ceremony around converting the types of well, not just the types, but the representations of the inputs and the outputs. It doesn't need to be that much ceremony. I could probably do that automatically. So that would be good. Oh yeah, and the final thing here is, like, if I can get to the point where every single time we're storing a float, we're storing one of these instances of my float class that I've defined, then, like, we don't really need to bother encoding and decoding that to 32 and 64-bit integers. We can just store that instance. So that's maybe, I mean, that's, I suppose, an optimization that could be done. So yeah, I'm going to think about that as well. But anyway, it's this one that I wanted to start with. Is there anything down here? Oh yeah, some bits and bobs for float.rb. I do actually quite want to look at this as well, at least some of them. Some of these are just conveniences, like having default signs and default payloads for nans and stuff. Yeah, I'll come back to that. Let's take a look at. So I'm not going to spend the whole session today just doing more refactoring, but I do feel like I want to like deal with the worst of the duplication before I start, because I know I'm going to be piling in another 10, 15, however many implementations of new instructions. Like, I don't want the problem to go out of control. I sort of want to nip it in the bud now that I'm at a stable stopping point where I know that everything I've implemented so far works, I think. So let's take a look. Let's have another place to run the tests. Good. So yeah, what I wanted to look at here was, where are those float instructions? I mean, the organization here leaves a lot to be desired. But yes. So here's the thing I'm talking about, that we've got, there's a lot of ceremony around, all I'm doing really is adding or subtracting or whatever these numbers. But there's quite a lot of sort of syntactic noise around it. So I'd quite like to find a way to sort of to tidy that up. I was also sort of conscious that in these implementations of these operations, I was just sort of frantically cobbling these together in the last stream. But they have a lot in common. You know, unsurprisingly, min and max are very similar. It would be nice if I could consolidate those. You know, floor and seal are very similar, and trunk, and nearest actually. So there's lots of it's basically the same shape of solution, but with just small changes. So I think if I could do a little bit of shuffling around of this code so that the bits that differ are more sort of isolated, and I can just sort of consolidate them and have like a conditional that just picks the right operation at the right time, that would be quite good. I actually did have this, looking at this has reminded me of, this is just a little nit, but I think this is the kind of thing that last time Ufuk was being really good about spotting these places where there was sort of more specificity than necessary. I noticed when I was reading through this code that here what we do is we say, if the value's 0 and it's a -0, then return the value, otherwise eventually fall through to square root. But of course we don't care about, here it doesn't matter if a +0 gets through here, because a +0 is just going to lead to a positive square root 0 if we do fall through to there. So I think that bit at the end of the line is unnecessary. At least that was my interpretation when I was just reading it. Yeah, so we definitely don't need that. I mean, that's not a huge win, but it does make it slightly, you know, it's one fewer thing to have to deal with. So that's a little tidy thing to get started. What did I put in the thing? Don't care about sign of, oh, so don't bother with negative sign. Check in F32 square root. 0 is the right answer regardless of its sign. Okay. All right. Well, that's not a huge win, but it's something. So I think what I want to do is find ways to sort of clean up these methods here, look for commonalities and kind of try and find ways to make the similarities more obvious. I mean, this was sort of the example I was talking about before. It sort of feels like these four, floor, ceiling, trunk, and nearest, should all really be similar. Like, they're all doing basically the same thing. They've got the same guard at the front for the special values. Like, in all of these cases, I think, if you call it on 0, infinity, or nan, you just get the original value back. So we should definitely be able to share that between the implementations. There's also something going on, not with floor actually, but with the rest of these. Like here we just compute the floor. What's really going on here is that there's a sort of a post-processing. Yeah, like in seal and trunk and nearest, what's happening here is that we say, we do this sort of pre-processing to check for special inputs. And then there's this whole like separate bit of handling here that says, because you see we've got value.seal showing up twice here. And I think that's sort of slightly obscuring the fact that what we're doing here is we compute the ceiling, and then there's this like little post-processing step here that says, well, basically, did we get a 0? And if we did get a 0, did we get a 0 from the negative side? So was the input negative? And then if so, I think we can make that more clear by saying like, let's call this result. So if, well, yeah, so it's this value.seal. So let's switch this conditional around and say if result is 0, why? I don't understand why Vim is insisting on outdenting the code I'm writing there. It's because I forgot to type do. So that's actually quite useful, thanks Vim. So if we got a 0 result and the original value is negative, maybe input would be better than value here. And maybe output would be better than result. It's okay, I'll stick with this. So this is this condition, right? So this is sort of pre-processing for special inputs. This is sort of post-processing for a special output. So this is saying, if we get a 0 and we've approached it from below, then we need to return -0. Otherwise, we return the result. And I think this code is doing the same thing, right? And the only difference is, I want all of that. The only difference is that instead of calling seal here, we're calling truncate. And again, here, okay, so this is slightly more, well, I mean, it's still the same. It's just we pass an argument. We pass half even to round, else round half even. So I think this makes it clearer what's going on. And now we're not duplicating. I suppose this is probably slightly more efficient as well because we're not computing this expression twice. But I think this does make it clearer that we have like an early return here for special inputs, and then we've got this post-processing step for the computed result. So I'm hoping the test will pass. In fact, it's a little bit wasteful for me to be running these tests. Why don't I just run F32? We don't need to run all of the other stuff. Okay, yeah, so that's all still okay. What's special about floor? sort of interesting, isn't it? Because I'm not actually going to leave this in. But in terms of similarity between these things, I think this will work. I think putting that same code in to floor is going to work because it doesn't do anything. Like if you've got a 0 floor, you never approached it from below. You always approached it from above. So this condition is never true in the case of floor. But so I'm not going to actually put that there. But what that suggests to me is that I think it would be harmless to consolidate all 4 of these things into a single implementation, and then the bit that varies in the middle is if we don't have a special input, we just compute the right result here. So I think I already ran the tests on this. Yeah, so let's say compute seal truncate round only once. I'll say something like what's the right language here? Something like we pre-process, in each case, we first check the input for special values, then compute the output, then check for a particular special output, i.e. -0. So now I want to see if I can fold these together somehow. However, it does occur to me that all of these, not just those ones, but actually everything I implemented last time, they all have with float wrapped around them. So I think there is a straightforward opportunity there to just sort of hoist that outside of this, like all of this, I think, all of that code, every single case has got with float inside it. So if this was in, like, what I just said isn't true for these the ones after these. I'm not using the with float helper down here. But if I say in add, I'll come back to that. But the point is that this would be all of the add sub, all of those operations I implemented here. And then this whole thing would just have a big this whole case statement would just have a big with float around it. Oh yeah, okay. I was a little bit confused about the indentation, but I think that's right. So, sorry, I'm not being very clear about what I mean here. All of these can have with float. I can just pass in whatever the arguments are and get those yielded to the block like that. Is that what I want? Yeah, I think so. And then that means that these can all just be so this pattern match is going to pull out. So if we get these sort of splattered arguments, I don't need to bother matching them here. This will just pick up the value of arguments from the outer case. It will convert them all to floats. All of these, I can lose the with float. And I mean this is maybe a bit of a distraction from what I was trying to do, which was consolidate some of those floor and seal and stuff. But it's making all of them smaller, so consolidating them is going to be inherently easier, I think. Okay. Yeah, I mean, the amount of duplication here is already sort of wasting quite a lot of my time. Oh, look, I didn't need to... I didn't need to indent and outdent everything because all of this has landed at the same level of indentation, because it's got indented one level but then outdented again because I've taken away that with float block. So if I'd noticed that sooner, I could have avoided a lot of mucking about with Vim. So what is it? Mul, div, min, max, square root, floor, ceiling, truncate nearest. So, I just realized I need to indent this again. I'm in danger of my indentation getting out of control here. So that whole case statement needs indenting one more, because this is all inside a with float block now. So we're in the float operations generally, and the first thing we can do is pick up an arithmetic instruction, essentially. And maybe I should pull out a constant, extract an arithmetic operations constant. And if we match that, then we go into one of these with float blocks, and then inside that we check to see what the operation is, and then we can it's just straightforwardly like, we've got two floats, we can just add them or subtract them or whatever, and then on their way out of the block they'll be converted back into our underlying representation for floats. So I think that's, although the indentation is starting to get a little bit deep, I think that probably does improve the situation somewhat. Oh, it was called... Oh, that's interesting. Okay. Oh, I didn't realize I'd done this. I had this taking left and right arguments, but I never used them. And I guess that's true for max as well. Okay, all right. Well, that's kind of naughty. I don't want those local variables if I'm not going to use them. I think it's worth, rather than doing asterisk here, I think it's worth sort of representing the fact that min and max are binary operations. They take two arguments. But we don't actually need them, and we've already got an array with all the arguments in it. But it's not called args, it's called arguments. So where was args? Oh, right, that was the block argument for the with float helper, right. I was like, where was that coming from? Because what it is called in the outer scope is arguments. So we'll just do that. So this will just be arguments, blah, blah, blah. Okay. All right. Well, that was quite a lot of surgery. So let's just see whether it still works. Oh. Is that because I forgot trunk in the... Yes. Well, I didn't forget it. I just spelled it wrong. Okay, great. So what is this then? This doesn't feel like a massive improvement, but I guess it is actually making this code quite a lot shorter. It's a bit hard to see that here. Right. 64 insertions, 84 deletions. So we're kind of coming out in favor of, I guess, all of those with float lines and all of those end lines have been removed. Push all float arithmetic operations inside a single with float block. This removes a lot of with float something comma something do something comma something end boilerplate. Okay, I'm happy with that. And now it feels a little bit more tractable to go back to those operations I actually wanted to work on, right? Like I feel like I've taken away some of that stuff that wasn't really relevant to the specific operations that are being performed here has now been lifted out of this, and I don't need to think about it anymore. So I'm pretty sure if I just, I'm not going to commit this, but I think if I just temporarily go back to this thing that I had where floor was being treated exactly the same as those other operations, it feels like if all four of these are identical apart from the operation that's performed, then I think I can just extract like this bit, right? Like what I mean is I can have one consolidated implementation of this that is for floor and seal and trunk and nearest with some input value, and then it can look pretty much like this, and it's only this bit, this value.floor bit, that needs to change. In fact, what this can be is case, what is it, operation, and then this can just be chained onto the end, like do the operation and then do this sort of post-processing step. I think that would be fine. And then I can just delete all of these other ones. So this could be like in floor value.floor in it's hard to remember what order these are in, seal value.seal in trunk value.truncate. I mean, like with these two, there's a bit of a temptation to do some meta programming because the method name in Ruby is the same as the string, but that's not true here. And it's doubly not true for nearest because not only is the method not even called nearest, it's called round. We also have to give it this half even argument. Yeah, okay. So now, hopefully that case is actually sort of blocking all of these. None of these can run now because they're all sort of preemptively matched by this one. So hopefully they weren't doing anything anyway. Yeah, I mean, to me, that feels like surely that's a significant improvement, right? So let's say combine floor, seal, trunk, nearest implementations. These are almost identical in the handling of special values, differing only in the underlying operation. We don't actually need any special value handling for floor because you can't get a floor of 0 when you start with a negative input. But it doesn't do any harm, so it's worth including for the sake of regularity. I think that expresses my feelings about this. Okay, that's cool. Well, so what about the other instructions then? Like I said, at the very least, min and max are very similar. I mean, it's sort of, it's tempting to do something for, well, what would I do for I was going to say add, sub, mul, and div. Like, I guess I could make that a little bit more concise, but only by like adding cleverness. You know, I could say like, oh, we have a hash that maps the operation name to a symbol that names the method to call, and then we're going to send that message to the left thing and pass in the right thing. But like, I think in terms of clarity, this is close to optimal. So I think I'm going to leave those ones alone. I'm a little bit more concerned about the duplication here because, and also I don't really like what I ended up, this kind of or chained onto the end got me where I wanted to go quite quickly, but I think it's a little bit, it makes it harder to understand how this thing is working. So if I can firstly clarify the implementations of these and then secondly combine them, I think I'll be happy then. I think that's probably enough cleaning up here. Like, it was mainly a desire to collapse these 4 ones together, which I've already done. And then if I can deal with min and max, I'll be happy about that. So so I think something that's a difference here in min and max between what I've done in this floor and ceiling thing is that here I have this little pre-processing step, right, that says that checks for unusual inputs. So it says if the inputs are 0 or infinite or nan, and then it returns something acceptable. And same with square root, right? We don't really, well, I suppose we do have that here. I think what I would like to have here is, I want to try and simplify this because it's a bit confusing, and the most obvious thing to do, I think, is to, the simplest check here is to see are any of the inputs nans, because if they are, then you have to return nan. So I think what I can say here is if any of the arguments is a nan, you know, there are only 2 arguments, then here, does it matter which one I return? I suppose I could just run the test to find this out, but like, am I just returning oh no, I pressed E or something. Let's see, f32.min. Oh, min is the function name. So under what circumstances do we get a nan, and what does it look like? Okay, yeah, so this is saying we just get a canonical nan, we just get an arithmetic nan. So it does look like if one of the inputs is a nan, we just get, well, we get the canonical nan back. So actually, I think my implementation of this might not be right at the moment, and I think this might have been one of the things that picked up on is that because my tests at the moment are not actually checking to see whether the result we get here is a canonical nan, it's just returning this one. I think that's actually not right. So here's an opportunity for me to simplify that and just say, well, here we're just going to return the canonical nan in that case. Do I want to say else if here, or do I want it to be, do I want like a nested? I think where I want to get to is like a 3-clause conditional here, where it's like, what am I going to do about this 0 check? Well, let me just try this first. Yeah, I'm going to think about what to do next in a minute. So I suppose what I'm trying to do here is sort of separate out the sort of special, checking for special cases, right? The sort of having a pre-processing step that checks to see if any of the inputs are nans and deals with them, and then we don't need to, those aren't messing up the, because this is the real implementation where it says arguments.max, arguments.min. Like I would like to pull both. Well, I've pulled out the nan check. I would like to pull this 0 check like more straightforwardly out, and just have a final else clause that says else arguments.min, because then I think this code is going to be much easier to read top to bottom rather than this slightly weird situation here. Oh yeah, and it differs in both those cases. Anyway, I think what I've done there, I think sort of extracting that nan check is a step in the right direction. Yeah, okay. So separate min/max, like nan handling as a pre-processing step. Yeah, and I don't think I need to explain that anymore. Like, hopefully it's obvious what that means. So now I can do that for the 0 case, right? Like, what this is actually saying is else if arguments are all 0, yeah, it's a little bit tricky. Like, we're saying, are the arguments all 0 and there's one of these? So, like, pick up the 0. Yeah, if the arguments are all 0 and... Oh, this is interesting. Okay. All right, I think we can improve this. But for now, we just pick it up and return it, else we return the minimum. And I think that this is the same here. And it's just that instead of looking for negative 0s, we're looking for positive ones. And otherwise we return the max. So now there's kind of 2 explicit pre-processing steps. It's like, are there any nans? If so, just short circuit and return nan. Otherwise, if they're all 0s and there's a negative one, then return it. Otherwise, do the regular min. The thing I noticed when I was pausing is that, well, let me check this is working before I... Yeah, okay. Well, let's just commit it. I think that's fine. again, it's making them similar, but this is now sort of separating the zero handling as a pre-processing step. Now, the thing that I think is interesting here is that if this part of the conditional fails and there aren't any negative zeros, then arguments.min is just going to return whatever zero there is. So, this is saying all of the arguments are zeros, but I guess this is saying they're all positive zeros. And arguments.min is going to return that positive zero. But we could do that here. Instead of saving this zero, like if we're not doing the detect, then there's nothing to detect. But this will return the right thing if we just say return. We can't just say return the smallest input, because Ruby doesn't know that minus the negative zero is any different from positive zero. So we can't just compare them. But what we can do is compare their signs. So if we say min by sign, that's going to return the zero that has the minimum sign. And in case you didn't see it when this happened, the whole reason it's possible to do that is because of this refinement. So we can call sign on a float, and then we're going to get back 1 or -1 depending on its polar coordinates, which is not worth getting into. But apparently that's the way that we're going to... Oh, I'm actually a little bit suspicious about that implementation, but it's not a problem if it's not a problem. So yeah, this is like, give us the smallest one based solely on its sign, because we know that their magnitudes are equal. Otherwise fall through to the regular minimum. And I think that extends quite nicely to here, where now we're just saying max by. So let's try that. Okay. Use sign to pick the minimum/maximum zero. Okay, well, these are now in a shape that I feel much more comfortable with. Like, that's definitely easier to read and to understand than what I had previously. And again, it feels much more like I can just fold these together now, right? It is massively tempting to use send here, because like what I want to do is find a way to make these two, the min and the max clauses here, look the same. I can clearly make this line look the same as this line by just using the value of operation, which is min and max, which is the exact name of the method that we're calling here. So if this was just send operation, and same here, that definitely works. Oh no. Okay, I think I am going to do this. What I'm going to do is, this is going to be send. Well, let's do it a step at a time. Min by. And this is going to be send max by. Right. But now this can have interpolation inside it. I don't know what happened there. I pressed the wrong thing. This max part can just be operation. Oh, this needs to be quoted. Thanks, Vim. And same here. So if I quote this whole thing, then instead of min, I can interpolate operation. I mean, I don't feel great about this. I mean, really, what I'm doing here is exploiting a property of Ruby, which is that it's the methods on Ruby arrays have got the same name as the operations in WebAssembly for minimum and maximum, but it's not. It feels like this is just on the OK side of the line, and actually, I think it is. Although it's a little bit gross, I might change my mind about this and want to implement this in a sort of in a less dynamic way, you know, because this is essentially just like case operation in min arguments dot min by, you know. Maybe that would be a little bit less gross, but for now, I think that just keeping this concise and making it really obvious that it's just the operation being applied to the sign of these values, I think it's clear enough, and it's pretty concise, and I'm pretty sure it's right. So that was all working, right? See what I mean about having to wait for the parser? I really don't like that. So now I can just catch both options in there because the implementations are identical. Great. So I'll say combine min max implementations. These are essentially identical in their handling of special inputs, differing only in whether they call array min or array max, or min by, max by. I'll just call it. I don't even know if that array is on, if that method is on array. Yeah, it is. Okay. In the case of zeros. At the moment, I'm doing this dynamically. I'm being a bit lazy and using send to pick since the names exactly match between WebAssembly, since their names exactly match the WebAssembly instructions, but in future it might be better to maintain a lookup table to make the code even more explicit. Yeah, I might come back to that. Come back to use of send in min max implementations. Well, reconsider. But for now, it's gonna allow me to make progress. So I'm fine with that. So I did this don't care about sign of square zero and square root. I did this consolidate near identical implementations of float arithmetic operations. This is about integer operations, which I feel a little bit less motivated to. I will come back to these, but it's sort of a bit further off the beaten path for me right now. Extract a helper for dealing with unary operations, which are the identity. Oh, well, I mean, what I was talking about there was writing a helper to do this so that it could be reused in the implementations of floor and seal and trunk and nearest. But actually, it's only being done once, so that does not need to be done anymore. So that's good. I've kind of killed that thing without meaning to. I mean, I've done some of this unified type conversion of inputs and outputs in that I've consolidated it for this whole chunk, but I mean, I certainly haven't thought about it for these, for example. These are all still having to do their own conversion of the types and encodings of their inputs and outputs. This feels like a little bit high-minded for what I was hoping to do right now. Store floats as Wasmina for instances. Sort of an optimization. It's not gonna. I don't think this is gonna materially affect the complexity of what I'm doing here. This might reduce a bit of duplication because, you know, at the moment that with float, well, no, we still have to have this with float helper. It's just that it would do less, you know. At the moment, this is assuming that what we get are integers that have to be run through Wasmina float decode, and then we call 2f on them. And this would instead turn into, well, they're already Wasmina floats and we're just going to call 2f on them to get Ruby floats. So I think that's got a very localized effect in terms of making the code cleaner or shorter or anything like that. It's mainly just avoids a load of conversions back and forth. So I'll come back to that later when inevitably I get frustrated with how slow this is running. But at the moment, I mean, at least on my relatively speedy Mac, this is running relatively fast, so I'm okay with it so far. So what else did I have? Yeah, in float.rb. I mean, there was this stuff at the top about, yeah, the test runner. I would actually like to clean that up at least a little bit. I mean, just putting colors in the test output would be better than nothing. Deduplicate the refinement. Yeah, I've got a mask helper that's duplicated. This was just speculative. This isn't really important. All of this feels like kind of nice to have rather than really meaningful. Yes, again, some of these are really, I mean, this is literally just about the naming of variables. The two things I'm interested in here, I think, are use rational in approximation and reify sign. So this use rational in approximation is just an observation about the fact that I replaced numerator and denominator pairs with rationals almost everywhere, except in this approximation class, and not for any clever reason. I just never did. It's pretty localized, but I feel like being able to unify this as a concept and say, like, everywhere that I'm thinking about a quotient between two integers that is always represented by a rational, I think has some sort of, it reduces the cognitive overhead of like understanding what's going on in this code, because you have a single concept, which is a ratio between two integers, and that concept is represented in the same way everywhere. And at the moment, for just historical accident reasons, that is not the case here. So I would quite like to make that change. The thing that I'm slightly more interested in is this reify sign. And what I mean by that is basically make a sign class, i.e. make a sign class. Because at the moment, we've got... it's called float sign. At the moment, we've got this notion. So sign returns, when you call sign on a float, you get back, I mean, yeah, do we really need a class for it? Maybe it's just, well, the point is we've got this concept here of a sign, and it doesn't have an official representation in our program. Like, we're just using the numbers 1 and -1 here sort of arbitrarily because they work. Really, all we're doing is calling positive and negative on these, I think. Um, what do we actually do with signs? End of a word. Yeah, we ask it if it's negative, and what about in... What's it saying? Oh, that's because here it's all... Oh. Was this the only place... I guess these are the only places that we're using that refinement. It's like in here, in min and max. Yeah, and we're not even asking... Oh, okay, so actually, because of this change that I've made, we're not just asking it if it's positive or negative anymore. We are actually using it sort of... its magnitude as part of this. Well, not... We're comparing these with each other now. That's what's making this piece of code work. So we're sort of... Yeah, I'm sort of talking myself into this, that I think having a class that represents... that makes concrete the concept of a sign and supports exactly the operations that we need a sign to implement, and only those operations, I think will make it clearer what this thing is. And the other reason I'm interested in it is that I'm conscious we've got a related concept here called negated, which is a Boolean, and I'm not sure that there's a good reason why we need both of them. I think that this could, if we had a sign class, then I don't see why this, all of these float classes, I was looking for finite, but, oh, well, finite's the only one that hasn't got one. All of these ones that have got a negated field, like, that could be a sign. And then we wouldn't... Oh, well, maybe here we would, because this is the parser. But in general, we wouldn't have to think about converting back and forth. Like here, if I got a sign back from unpack, at the moment I get a Boolean, which has to be created by unpack anyway. So if unpack could create a sign, then... possibly in some of these places... Oh, because I'm making a finite there. Maybe it doesn't really matter. Maybe that won't have very much impact, actually. I mean, if I make the change, we'll be able to work it through and see what it actually affects. But, okay, so perhaps it's more of a conceptual problem than a practical one, which is that I just don't like it that we've got two different concepts here. We've got the Boolean that tells you whether something is negated or not, and then we've got the sign that tells you whether something has got a negative or positive sign, and that feels like there's an overloading of a concept. And actually, I hadn't even realized that I was starting to use the sign differently here. I didn't even really think about it, but because I knew it was a negative or a positive number, I was able to use it in... I was able to use comparisons on it to tell the difference between positive and negative zero there. So what am I actually talking about here? I feel like I've gone too far. I know that this is going to be needed in two places. I'm going to need it in the interpreter and in float. And I feel like I've piled in too much. I've already got the mask helper, and I've got that, this refinement that sort of have been copied into both files. So I think I'm going to start moving away from that, because these files are getting pretty unwieldy now. So let's make a new file, sign.rb. It's going to have a sign in it. Should this be a struct? Should this be sign equals struct.new? Well, actually, maybe I've been a little bit liberal with the use of structs so far, because, like here, I've got a struct that represents a format, but actually there are only two instances of it. Maybe in this case it's justified because these have sort of interesting accessors, but these are supposed to be immutable. So actually I think, yeah, I didn't really think about that. I just did this on autopilot when I did this before, but now that I'm thinking about it, if what you want is something that's going to be not only immutable, but also where you're not really allowed or supposed to make your own instances of it because it just represents, it's not a singleton, right? There are multiple singleton instances, if you know what I mean. There are only two formats that we support, which are single and double. I mean, that could have half. It is possible to add more things in here, but the point is, it's not for the user of this format class to make those instances. These are supposed to be the ones that we support. And I think there's a similar situation going on with sign, where it's like, I mean, the real reason I stopped is because I couldn't think of what I want is this going to be a negated flag, or is it going to be a sort of integer that represents the sign? I'm not quite sure. But it doesn't really need to be a struct at all. Like, we can just make a class, and then we can say, like, well, what we can say is, firstly, nobody's allowed to instantiate this class. So if I'm here and I try to say sign.new, it's like, no, you can't do that. That's not allowed. Like, that feels like a good starting point, is to say, like, well, there's only going to be two of these and you're not allowed to make your own signs. That's not a supported concept in this application. So what are they? They are, so like I said, it's sort of like having a singleton, but there are going to be two of them. Are they positive and negative? So that's another thing I'm not entirely happy with, because the sign is subtly different from whether the number is positive or negative, because, the positive and negative, like a 0 is neither positive nor negative, but it still has a sign. So I think there's something a little bit perverse about calling them positive and negative. I just got slightly distracted because I saw that James asked a question probably an hour ago in the chat. Sorry, James, my chat was not scrolled to the correct position. You asked, why do you write the top line of the commit message in the shell, but then enter the body in your editor? I don't know. I think it's because, well, I mean, it's just a habit. I think the habit is that why do I do that? I feel like it's like, yeah, I probably shouldn't do that, should I? I think it's like, what I want to do is just get the commit made. I want to make it. Really, what I would like to do is sort of make a commit with an empty message that's just sitting there with the diff in it, right? So it's like, I've made the change, I've got the test working, right? That's a commit, and that's what I use that sort of git c whatever, hit enter. Like, I've made the commit, and then there's almost, I don't have any justification for this. I'm just trying to retcon why I behave in that way. I think what I'm doing is sort of wiping my brow and saying, okay, the commit's made. Now I can recline in my leather armchair and think about what I want to write in the commit message, which is going to be a couple of sentences or a couple of paragraphs, depending on how detailed it is. And that's like, I don't know. I think I feel a little bit of comfort that the commit is like already made at that point, and so if I bail out of that, for example, if I can't think of anything interesting to write, then that's okay because I've already got the commit. So I think, I don't know, now I feel like I should push back on that because it's really not a rational habit, but it's just what I do. Oh yeah, I was saying about the names of these signs. I think what I want to do is call them plus and minus, basically. I think the idea of having a plus sign and a minus sign in front of your number is very closely connected to the number being positive or negative, but like slightly different. And this is an opportunity for us to name this thing. You know, this is more like almost like the character that you're putting in front of the number, you know, the plus or the minus sign. I mean, I think that's what they're called. What does Unicode call them? Unicode plus sign. Plus, yeah. It's called plus sign. Is there a minus sign in here? Oh, there's a plus minus sign. Yeah, okay, there is a minus sign. So I sort of feel like, you know, this doesn't have positive sign and negative sign. It has plus sign and minus sign. So I feel like even though it feels a little bit primary school to refer to them in that way, apparently that's what they're called, and that's why they are referred to that in primary school. So maybe that's okay. So I can make 2 instances of my class, and then unless I make more of them inside here, no one else is going to make any because the new method is private. So how do I want to deal with this? I need both of those to respond to positive and negative. So I still do have to make this decision about like what's the underlying representation. How do they know that they're positive and negative? I mean, I could just literally say, you know, like that. Oh, but we're going to need this because that's what sort needs. So I have to be able to compare this to something else. And so I'm going to have to... What I don't want to be writing in here is like, you know, if other equals minus, you know, I don't want to start getting into that. So I think what I'm going to do is give these a sort of a number. So this one's going to be +1. And this one's going to be -1. Oh, Vim, you don't know about Ruby. And do I need this, or will these get coerced? Let's see I can see what methods I need on here. Like maybe allowing this to be coerced to an integer is enough to make this sorting work. I can't remember what else it was being used for. So I'll leave it at that for now. Where was I actually? Oh, look here. Oh, that's in pack. This is what I was looking for. I would like to return an instance of the sign class here, and I guess what I can say is angle 0. Oh, I said I was a bit suspicious about this. Angle 0 is sign plus, and this is sign minus. So that like plug it into this, and I'm copying that because I think I'm going to want to do the same thing over in the interpreter. Requires sign, and yes. So that kind of plugs in the sign, so that at least in those places, so I haven't touched the implementations of floats or anything, but the places where we use the refinement, we're going to get an instance of this sign class rather than a +1 or a -1. So really, this is just a very thin shim around a +1 or a -1. But I don't know. Well, let's just run the tests. I don't need to delay the inevitable. Okay, so we do in the interpreter, as I'm sure I saw a few minutes ago. What line number was that? 369. Oh, it's actually 105. Sorry, that was the wrong part of the stack trace. In float.rb. Right. So we do ask if it's negative here. And I think that's okay. I think the reason I'm pausing is that, like, what if we were just getting the sign off the float here? We wouldn't need to ask whether it's negative. But I think in the interests of making a small change that works, what I'm going to do here is sort of delegate these methods to the integer representation. So, and I mean, that's not an unreasonable thing to do, right? To ask whether the sign is positive or negative. So I think it makes sense for these to be implemented here. So min isn't working. Comparison of sign with sign failed. Right, okay, yeah, that's because I do indeed need this. But this is just going to be what? Well, my integer representation compared to their integer representation, basically. So again, just delegating this to the integer, but on both sides of the comparison. Okay. So that is working. What has that given me? Well, like I said, I think two things. Firstly, it makes it clearer what this is being used for, and particularly if these values make their way somewhere, it'll become clearer that what you've got in your hand is an instance of the sign class rather than just arbitrarily the number -1. So I think that's an improvement. And the second reason is that I would like to be able to use this instead of that negated flag in my implementation of floats, which I haven't done yet. So this is just like a step in that direction, I suppose. But this works, and I think it's all fine. I haven't got a unit test or anything, but like, it's fine. This hardly does anything. And, you know, the only stuff well, with the exception of positive, the only stuff I've put on there is stuff that's being exercised by the existing code. So I think I'm just going to let that one go. Introduce sign class to concretely represent plus minus signs. It makes me feel more comfortable to have this concept modeled explicitly rather than using the integers +1 and -1 to represent signs. It's more explicit that these instances have a specific purpose and shouldn't be used as general purpose numbers. I think. Well, not so much used, thought of. I mean, I've just done, even though James asked me about this, I've just done the same thing again. So clearly I just don't have the muscle memory for anything else, is maybe the simpler answer to why I do things that way. Okay, so the reason I was doing that, though, was to see if it was possible to plug it in plug it into the existing float implementations. I'm also just thinking, now that I've got a separate float class, maybe this wasn't part of my reason for introducing it, but maybe the refinement could live inside it. Like maybe what we could do is say, if nothing else, it would help me to deduplicate the, if in here I had, I guess it wouldn't be called sign. What's the refinement called? Float sign. Well, given that it's inside sign, I think it'd be a bit weird to call this float. Let's call it conversion. So, and then we don't need that prefix anymore, which is nice. Namespace. So sign : conversion is now the refinement. And there's also one in the interpreter. Does that still work? No, because it's called sign conversion. Okay, good. That's just opportunistic. I haven't really added anything, but I've done this. So let's just move float sign refinement to sign conversion. Do I need to say any more about that? I suppose this is part of it, James, where it's like, I write my basic message and then I'm like, do I have anything to add? I don't think I do, I think I'll just leave it at that, but I can tick this. So that's the main thing. So I have reified sign, i.e. made a sign class. Well, I didn't say anything about using it in float, but that was definitely what I was thinking, was all these places where we're saying negated. It would be nice if we could just use it there. The problem is that there's going to be a few places where we're making negateds. So that's one place. If the float already, oh, this is a Ruby float. Never mind. Right. So like here. And here. Actually, this should just be negated. Reuse negated local variable in, what is this? Float parse. I think this conversion from strings could be done inside here. I think if instead of this, I had like sign. It's already called sign, isn't it? Sign for, like, the sign whose name is whatever we matched in the regular expression. Oh, and then I need to know, hold on, what did it say before? Right, okay. So it's like, at the very least, I want to make a connection between this negated thing here and something meaningful to do with sign. So this is asking whether the sign being represented is negative. Where else does that happen? Right, so there's another one here. Sign for, name, sign, negated. And another one here. Sign for, name, sign is negated. I know this is a bit clumsy, but what I'm trying to maneuver towards is a place where we can just replace all of these negateds with a sign. And this is a maneuver that gets us closer to that, because now there is an instance of sign sandwiched in the middle of this expression here. But at the moment, we're asking whether it's, oh, it's, the method's not negated, it's negative. All the more reason to get out of this situation, I think. So at the moment, this slightly clunky thing is just correcting the API mismatch. If I can push through sign so that it lives in those floats, then this bit of code will be much less messy. Yeah, again, if this was a sign, then we could be doing something a bit more. Let's just look for all of the places where I'm. So what's this? Yeah, so a similar thing here. This exponent sign isn't actually an instance of sign, but here if I can say if the sign for the exponent sign is negative, then do this. I think it looks like that's all the places that it's being, that we're converting from a string to currently a Boolean. Yeah, does that still work? Oh. Okay, I was very optimistic in writing the code that I wish I had, but I didn't then take the time to make that wish come true. So I'll make that wish come true now. Def self for name. I mean, this is what we were doing, right? How do I want this to behave? Yes, this is how I want it to behave, because, well, firstly, this is just reproducing the code that we saw elsewhere, but also I think it's important that this also means that plus is the default. So if we get anything that we don't recognize, or we get nil, or we get the empty string, then plus is going to be the answer here. And maybe it should raise an exception if it gets something other than the plus sign or the empty string. But like in the first instance, this is going to give us something that's more obviously correct. In particular, this gives us the behavior that if the sign is not there, then implicitly it's plus. That's what we want. And it kind of that was the thing that was bothering me about this, is that everywhere else in the code we sort of have the negative case first, but here we've got the positive case first, which is kind of makes me a bit uncomfortable, but it doesn't matter. Okay. So this has gone one step towards, I feel like this has got a grip on those negated Booleans, at least in this specific case where we're just making Booleans to tell us, from a string, to tell us whether that sign is a negative sign or not. Like we've kind of pushed that functionality into that sign class now. From string to sign instance. Potentially empty sign string to sign instance. Again, that's the sort of thing where if I had a unit test for that, it would be better, but I just know that these unit tests that we are executing with this do that all over the place. So I've already sort of got a million unit tests, not ones that are testing that specific thing. But, see, imagine, I thought this was a failure, but it's not. It's failed successfully. But there's, again, because there's no color, it's very hard to spot that. Okay. So having done that, is there now any mileage in pushing it through onto the float so that I've just got sine everywhere? Let's at least see what that would look like. What were the classes? Nan. What's the first one? Okay, infinite. All right, so if I make this sine, what's the right? I suppose I'm just going to do a straight swap in all these places. I feel like it might be worth coming back to this. But for the time being, I guess I can just say, I can just check to see if the sign is negative, right? The thing I'm thinking about it here, though, I'll come back to this, but this is just, this conditional is just the product between it's the sign and the underlying value. So I think I can come back and clean that up later, but I'll leave that right now. Do I want to push this through to pack and unpack? Yeah, I think I do. I could do it in separate pieces, but it's just going to involve more typing for no real benefit. So I might as well do a single thing here, which is the whole point of pack and unpack is that they know how to convert between whatever it is that the floats use and whatever it is that goes on in the underlying IEEE 754 encoding. So it would be a bit silly for me to make this negated is sign negative. Life's too short. So I'll have to go and change encode pack, and I guess I'll have to change unpack as well. So this has got a sign, and just find all the uses of negated. So Nan doesn't care about the sign at all. It just passes through untouched. This does care about it. Oh, because we need to know. Right, the reason why Nan doesn't care is because we can't make a negative float anyway, a negative Nan anyway, so we'll just leave it. Sign goes here. Oh, this is interesting. What do I want to do about this? The fact that we're calling negative. I'm not quite sure how I want to deal with this. Because what I actually want here is a sign. But how am I gonna convert it? I'm not sure what I want to do here. I guess I'll just instead of doing this, I'll just sort of manually make a sign here, which isn't great. It depends upon knowing from outside of this class what these instances are. But I just can't think of a... I mean, the most appealing option is to just refine rationals so that I can call sign on it. But I'll leave it like this for now and then maybe come back and do that refinement. So this takes a sign. Okay, so we're back at the... Well, now we're on the other end of this problem, right? Where it's like the floats... I think I'm at the point now where the floats are all... Yeah, infinite, sine, sine, nan, sine, sine, 0, sine, sine. And then finite doesn't store the sign explicitly, but it knows how to derive the sign from whether the rational is negative or positive, which again, I think I do want to refine rational, but I'll come to that. So now I just need to make it so that this takes a sign argument, and this returns a sign here. Well, this is actually a sign bit, isn't it? So we're going to have to say it's a similar kind of deal to what I just did. And then this can be... I think that's okay. I'd sort of intentionally separated this out so that like there's the pulling the bits out of the bit field and then the sort of conversion logic and then the... now this... I think I'll come and fix this in a minute. That I think exponent is weird here. Like the local variable names are such that we use the same name and then we just convert it, in this case, to an object of a different class, but it keeps the same name, whereas here the conversion, the variable name's different, which I was trying to work out what that meant, and it doesn't mean anything. It's just an arbitrary decision I made, so I might go back and change that in a sec. So what do I want to do here? Oh, so we still need a sign, but now we can ask if the sign is negative, and if it is, then we do the 1 and the 0. So firstly, let's see if F32 is working. No, negated 184. Oh, right, I missed some... Oh, this was the thing I was talking about. Okay, so now this can just be sine and get rid of the negative on the end. This can just be sine. Negative. Not quite so great. This can just be sine. This can just be sine, and we can get rid of the negative on the end. And this can just be sine, and we can get rid of the negative on the end. And these are all... Oh, look, this just becomes sine equals float dot sine. And then these are all expecting to get a sign now. Except what happens with the... Oh, no, this is okay because the rational has already got... I was like, how do we get the sign in here? But the sign came from the float. This was always supposed to be a signed rational, so actually we only need this in these three cases. That's all right. So this doesn't take negated anymore. It takes sine, or it returns sine rather. So this is where we're unpacking. So this has to be sign negative again. I think that's it. Yeah, I just hadn't finished. I hadn't found all of the places that it was that the sign was being used. Okay, great. The only thing I'm slightly skeptical of is how come the unit tests don't mind about this? Oh, is it because I haven't run the... Yes, okay, all right. That makes sense. I was like, I've changed the API for this, so I'm pretty sure that the unit test was going to have a problem. Float test. Okay, so here, this has to be sign plus. Okay, that's good. I thought something had gone wrong with my brain. Okay. Pending test failed successfully. All right. So I'm not quite sure how to summarize this change. Maybe rather than writing an essay, I will just say store sign not negated on float instances. Yeah, I think that's okay. And then, I mean, that when you actually read the code, you can see that that's pushed through to the encode and the decode methods, but I don't think that me typing that into the commit message is going to make it any clearer, because I'm just describing what is happening in the code when I do that. Okay. So I'm gonna, I know this is silly, but I'm gonna get rid of this biased exponent local variable, because that kind of tripped me up for a second there. And then this can just be like this. So I think this makes it clearer that we're just adjusting on the way in, and here we're adjusting on the way out. I don't think they need to have different names. Okay, that's all okay. Use exponent local variable throughout. Format, pack, and unpack. It slightly surprised me that exponent had two local variables associated with it. I don't think that adds much, so let's just use a single variable for each part and allow it to be reassigned. Yeah, I mean, the name showing that a bias was being added to it or removed from it was sort of a good idea, but it's so obvious from the code that's written that the exponent you get out here needs the bias removed from it, and this exponent here is having the bias added to it. Like, it's already self-evident, so it doesn't need to be reiterated in the name. The other thing that's making me slightly unhappy here is this sign. There's like a mapping between sign instances and the sign bit, and at the moment that's represented in two different ways here, depending on what direction we're going in. I would much rather say, like, the sine bit is sine plus is a 0. The reason I'm doing them this way around is because it's sort of in numerical order, right? Because these are the bits. So the sine bit for plus is a 0 and for minus is a 1, and then this just becomes sine bit dot fetch sine which has a sort of nice advantage that this fetch is going to throw an exception if we're past anything other than a sine instance here, so that's nice. And then if we want to do the opposite here, I think we can just do sine bit invert fetch sine, which again is very clearly the opposite operation when we're going in the other direction, rather than writing a different expression. And now now all that information lives in one place, so I think I like that better. So what did we do here? Extract sine bit hash in format. Do I want to say more about this? Yeah, maybe a little bit more. This keeps the mapping in a single place. It's my motivation for this change. Plus, it'll raise an exception if we get an unexpected input, which of course we're not expecting, but it would be nice to know if someone passes in, oh, you can't pass in, oh, you could pass in an explicit null. Or if we still had code that was accidentally passing in a +1 or a -1, we would actually find out about that now. But apparently we don't, because the tests are all passing, so that's good. So what else was on my... I want to stop refactoring now. I'm getting on for halfway through. What else was on my stack of things that I didn't like? Oh, I guess that thing in finite. Yeah, that we can't just ask the rational for its sign. I'm gonna do that. So here we can just say refine rational do def sign equals, again, negative, because we want 0. Rationals only have positive 0, so we want anything that's not actively negative should be positive. This is starting to look even worse now. Okay, so if I do that, yeah, where am I even asking? Oh yeah, here. Oh, that's interesting. I'll come back to that, but... Oh, yeah, okay, that was the other thing. But here, I think this can just be rational.sign, right? Which is not a huge improvement, but it is kind of nice. You know, elsewhere in the code, we can just straightforwardly ask numbers for their sign, and here there's an opportunity to do that, so let's do that. Support conversion from rational to sign. I don't think I need to narrate that any more than I have. So I'm a little bit worried about this. Partly because, I mean, this is completely arbitrary. I could have written this the other way around. But also, I'm not sure this even... The more I think about this, the more I think this doesn't necessarily give the right answer, because, well, it depends on how... It depends on what the polar coordinates are of, like, weird edge case floats. Like, what if I ask infinity for its angle, do I still get 0? Undefined method angle. Oh, sorry. Yeah, I do. And if it's negative, do I get pi? Yes. Okay. 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 Well, then that is, not only was it offensive to me, it was also actually wrong. So that means that if you ask for the sign, using sign conversion, which instance is that? Okay, so this is actually sine minus. So yeah, because of this implementation, because the angle of because a nan doesn't have polar coordinates, it just returns nan. This is defaulting to minus. And I think that's the underlying issue, is that the reason why all of these ternaries, why the other ones are in the order that they are, is because they're sort of testing for a particular case that we know is special to negative numbers, and then the sort of fallback for everything else is plus, and we need something like that here. So my kind of spidey sense about, so this should say positive. My spidey sense about that being different, I think, well, I mean, it's not like I was being clever, it was just a coincidence, but I was bothered by the fact that it was different, and actually it being different was not correct. So I think now, and the reason this is angle.positive is because then it'll be pi radians around the origin is where all the negative numbers are. So now, hopefully, using, yes. Okay, good. Make float to sine conversion work the same as rational to sine and name to sine. This makes the two methods from the refinement look more similar, but it also gives us the right result for nan, whose angle is also nan, and therefore not a positive value. Given that I've just done this in IRB, so, well, I suppose I fixed it now. So what I was doing was like float nan sine is equal to positive. Yes. Yeah, well, this is what we want. I guess I'll just show what we want. Like, that makes the point. Which doesn't seem to matter as far as the tests are concerned, but it's important to be right. It isn't. Okay, well, so The other thing that I was thinking about, like specifically all these places where we're asking if it's negative. Like I said, this is really just a... Oh, here we actually do need to know if it's negative because it's got a special meaning if it's negative. Oh, and but we're not asking the sign. We're just asking the exponent at that point. But here, I really should just be able to write this as... Well, I should just be able to do this. Like, if sine is positive, then we multiply the rational by 1. And if sine is negative, then we multiply the rational by -1. I think that would be better. Same deal here. And then that's a line of code I don't have to write there. I'm not sure what I do in this case. Is there a nice way that I can clean that up? I don't think so, really. It's just sort of tempting. I'm wondering if there's some way of cleaning that up that's like non-obvious. Maybe not. Yeah. Maybe I'll leave that. Oh, but here are some... I think this is where I first thought of it. Like here, this is just... And here, this is just 0 times... Well, I mean, at the moment, I can only make this work. This is... I don't... You know, I was just writing the code I wish I could write, but I think I'm going to need to do this, aren't I? I'm going to need to say... I'm actually thinking about the underlying integer in these cases, not the sign itself. But given that it has this ability, oh, I guess those are the only places that I'm actually calling negative. Okay, I guess that's fine. So what I'm actually doing here, these are all the places where negative numbers were being manufactured in Ruby. So let's just say make negative numbers by multiplying by sine 2i. Zeta says, could you do something like rational times scale to the power of sine? So where would that be? Well, here. Uh, hmm. Possibly. I'm going to come back to that. Because there's an obvious opportunity here to just deal with all of these, right? I think this is what I wanted to do. It's nice to see the test pass. But all of these places where I'm turning this into an integer, I could just allow that to happen by magic. I think that was all of them. Oh yeah, these are all to do with parsing. Because if I go into sign, well, let's see what the problem is. So this is going to say sign can't be coerced into rational in a multiplication. But I can just support that if I define coerce other. So this coercion protocol in Ruby, all the numeric types, if you give them an argument they don't know how to handle, then they will try to send the coerce message with themselves as an argument to the other object, and that gives me, the sign, a chance to convert myself to be compatible with this. So, you know, what's happened is that someone has called, you know, 3/4 times sign, and then what happens is that we call sign dot coerce 3/4, and then this returns a 2-element array, which might be, well, in this case, 3/4 and -1, and then the original thing is tried again, but this time with the two things that we got in the array. So I just need to return the original thing unchanged, and then myself converted to an integer. And then, yeah, I wonder if I should allow this. I think it's okay. I don't think it's going to cause any problems. Yeah, I think that's all right. And the code is like, again, less messy. Automatically coerce sign to integer. Just gonna go back and look at that. I want to think about what you said, Chris. Could you do something like rational times scale to the power of sign? Oh, I see. Right. I see what you're saying. That's really interesting. Let's see. Because I think that makes sense mathematically. Let's see what happens. Yeah. Yeah, I mean, you're right, Chris. This definitely is a mathsy way to reduce it. It's not working, though. and I'm not sure why. Because it seems like mathematically, it seems like it should. Yeah. Maths is being very uncooperative there, isn't it? Oh, it's because... Okay, I guess it's the exponent sign. It's the exponent sign. So that was my mistake. Well, I mean, let's see if that works. But... What? Undefined method sign for integer? Sure. Let's see this through and see if it's possible to make this work. Refine integer do def sign equals negative. I'm not sure if there's is there a common ancestor of these two classes that I could refine to get that behavior without touching float. Numeric is not it. Let's see if that works. Still doesn't work. I think this was a great idea. I don't immediately understand why it's not working. So I'm going to stash that. I would like to come back to it because I kind of like the idea of never really having to ask whether... Because this is the same thing here as well. It would be nice if we never had to ask whether a thing is negative, if we could just use the fact that it's negative in the computation. That would be great, but something about that expression I wrote wasn't right, and I can't get my head around it just right now. But I really appreciate that approach. I would like to make that work. Okay, well, I've been going for a couple of hours, so I'm going to, I think, switch into actually trying to implement something. Because right now, we're not making any progress towards actually getting those floating point numbers done. I feel like I've done enough, like, cleanup that I can actually stand a chance of, you know, implementing some more of those operations without it being completely... without it making a complete mess, basically. Okay, so... Sorry, I'm sort of saying one thing and thinking another thing, but what I was thinking about was where do we actually want to go next? It's a little bit confusing because abs is the first one here, but copy sign is the first one. But let's just start cracking on with this. I think I've already got the... well, I've got the pending test, but why don't I just run it directly, bitwise, right? Yes, copy sign isn't implemented. So I'll stop fiddling around with this for the moment. I'm conscious that there's still stuff on my... I've definitely comprehensively reified sign. I haven't looked at using rational in approximation. I haven't looked at any of this other cleanup. Think about using rational times scale to the power of exponent sign. Instead of asking whether the sign is negative. But I'll come, maybe next time I'll come back and do some more of these things. Or if I get this, if this turns out to be unexpectedly easy, I'll have time to do that on this stream. Oh God, I've got so many. Let me just close all of these so I can... Oh yeah, that's yesterday's news. Okay, so it's in the interpreter is where this stuff lives. Don't know how to evaluate copy sign. Okay. I think I'm going to keep going after my existing arithmetic operations. I mean, I know these are bitwise ones, but all of these were only added for conversions.wast. So I think I'm going to keep going with my slightly more straightforwardly arithmetic floating point operations here. So what do I want to do? Copy sign, left, right. Okay, am I in the right ballpark? Yes. Okay, so again, I could look at the spec, but what does this actually do? Well, it looks like it copies the sign from one number to another. And looking at these examples, like this one is the one my eyes alighted on. So the first argument is positive 0. The second argument is negative extremely small number. And the result is negative 0. So it looks like it's like target and source. So we need to take the sign from the second argument and splat it onto the first argument. So I think that's actually, well, so we could just do it in the same style as this. We could do a sort of with float, left, right format type solution. And then we'd need to deal with all of those well, maybe they're not edge cases, but we would certainly have to deal with the fact that I'm sure that there's a nan in here somewhere. So we'd have to deal with the fact that Ruby floats can't represent negative nan properly. So we need to have some kind of handling for that, because this information is actually lost. Like, we'd have trouble with this example because this negative nan here would just turn into a canonical nan in Ruby, and when we copied the sign onto the first argument, we would not get negative 0. So that would be a bit of a problem. But I don't see any reason for bitwise operations, which I guess all of these convert and demote and promote and things are effectively bitwise operations. We can just do these ourselves, I think, because we're just be manipulating the, well, at a lower level than the arithmetic operations do. We're just going to be twiddling the bits. So I think it's fine here to just do is this right? I'm just trying to remember how this decode operation works. I think you must give it the float and the format. That would make sense to me. Does that work? Yeah. So give me my own internal representations, and then, I mean, I think I probably can do this. The code, so not entirely intentionally, but again, just because I use structs to implement these floats, I think the easiest implementation here will actually work, that I can just say the sign of the left-hand one is equal to the sign of the right-hand one, and then the answer is just, it's left.encode format. So I just clobber the sign of the first one. I don't think we've done this yet. I don't think we've done this, like, actually, at the moment, I think we've only used the getters of these flows. Unless there's an example that I'm forgetting. I think we've only ever just assigned them through the constructor and then read things out of them. But actually, there's nothing stopping me from just using the setter to set the sign. So I would like to be able to do this. The obvious concern is that finite floats don't store their sign explicitly, so we don't actually have this. But, oh, of course, as usual, the worst possible situation has arisen, which is that all of these are finite floats, and I'm sure the special cases are in there. But whereas when it was inconvenient for me, they put all of the nans and infinite ones right at the beginning, in this case, it would have been convenient. Oh, but these are zeros. These are zeros, which have their own class now. So I think actually they've accidentally... I think these first four are probably going to pass. And then I think we're probably going to have a problem once we get to this, because when I ask a finite float for its sign, it doesn't know how to answer that. But what I'm expecting to see is the first four of... So, well, I know how to fix that. It's with programming. So here I can say sign, rational sign. So if you don't want to convert it to a float, but you just want to know the sign of it, you can just ask it. It would, I guess I could add this to my refinements, but that would be a little bit perverse given that this is actually my class and I can just implement that directly. Okay, and now we get the setter isn't defined, because this fourth example is... Oh, this must be a different example. Oh, yes, look. Loads of them have passed. So it's not until we get to... yes, look, the left-hand argument is a small negative number, and we're trying to copy the sign of -0 onto it. So that got us a load more passing tests. Now we need to do this. So we're going to have to update the rational. So I think the simplest way to do this is to just multiply it by the sign. Like if I take the absolute value of that rational and then multiply it by the sign, then the left-hand side is going to be positive. So this is the .abs here is basically saying throw away the existing sign information, and then multiplying it by sign is saying now make that the sign of it. So if it's positive, it won't change it. If it's negative, it'll make it negative. I think that's all right. For a moment there, my brain was like, oh, do we want to compare whether the sign is different and then flip it if it's different? But we don't have a way of flipping the sign, and this is easier, so I'm just going to go with this. Great, that's all of them. Implement the F32 copy sign instruction. Now I'm slightly nervous that I didn't read any of the documentation for that instruction, but I'm not that nervous because I think that's perfectly fine. It's just making me think about this. There would be more of a problem if we were storing these. It's fine for me to completely ruin this left, to diddle the sign of this left-hand operand, because I just constructed it myself. No one else is ever going to see this instance, so it's fine, and it gets garbage collected at this point. But if these were stored, if left and right here had come from the abstract syntax tree, then I wouldn't be able to diddle it like this. So I might need to think a bit harder if I ever do want to come back. Where was it that I said about using these Wasmina floats? Store floats as Wasmina float integers, not unsigned integers. Be careful about instructions like copy sign, which mutate the underlying Wasmina float. So I won't think about that anymore, but it's just occurred to me, so that's a little present to future me. What's the next one? Abs. Okay, well that's quite similar to this, isn't it? In fact, are these all going to be quite similar? Yes. 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 I'll just copy them for now, but I can see that these, it's going to be quite easy to consolidate these into a single implementation as well. Abs. And the reason why is because it's basically the same. It's just that this becomes sine plus. So the only thing that's changing is what we put on the right-hand side. He says without even running the tests. Oh. Rescue. What was the problem? Oh, it hasn't even vaguely worked. I was so smug about that, and I haven't even made a single one pass. Oh, it's because it's because it only takes. Okay, all right. Well, this is going to be a little bit more. Okay. Well, I'm glad I didn't try to preemptively combine these implementations. I mean, I would have realized soon enough, but of course, it is just this. So there is no second argument. Hey, it all works. Okay, that's easy. And then it was neg was the last one. Well, I think I can do this straightforwardly by saying, well, I could do a ternary here, right? I could say value, sine, negative, sine plus, sine minus. So I think that'll work. Yeah. It's just a bit of a shame, isn't it? Why don't I make it so that we can just do this? Because the whole point of having our own instances is so that we can do stuff like this, right? Like if there's some operation that we need, then we can just have it. And I think here being able to say, like a Boolean, I want to be able to flip this sign to be the other one. Why shouldn't I have that operation? And because there are only two instances, I just have to tell plus that its counterpart is minus, and tell minus that its counterpart is plus. Does that work? I guess it's the other way around. Yes, thanks, Vim. Okay, cool. Let me add that separately. So this is going to be something like implement sign. I can never remember which way around this thing goes. To allow a sign to be flipped. Do I want to say more? Yes, James, I do. I want to say we need this for the f32.neg instruction. Well, need is a strong word, but want. Yeah, let's say this makes the f32 neg instruction easier and clearer to implement. That's the name of the game. Okay, so now this is just implement the we're definitely going to get all these instructions working. Ooh, error, pending test passed. Of course, I need to also edit my test script and move this to here. Lovely. Okay. Great. That's bitwise dealt with. And now hopefully we can move on to the comparison operators. So that's done. That's done. Now we've just got equal, not equal, less than or equal, greater than or equal. Okay, so let's get it F32 CMP. Okay, no EQ defined. Add F32 CMP.wast to test script. Done with that. Okay, I guess we're just going to keep going here. So is this going to want to be... So can I put that in the... I suppose I can't... Sorry, I'm not being very articulate. I'm thinking about whether I can put it in here, but this doesn't return a float. It returns a bool. So I think I'm gonna need to do it out here, and I'm just copying this because it feels like it's going to be not a million miles away from this. So convert them. The thing is, I can test if they're equal without converting them to Ruby flows, right? I'm just trying to decide whether to... What I'm trying to decide is whether to just call to float inside here and just say, screw it, I'm going to operate on Ruby floats. I mean, it doesn't help that I don't actually know what the rules are here. Like, what counts as equal? Two numbers that are literally equal. Let's look at it's really the nans that I'm interested in, and the infinities and all that stuff. It's the same problem. These are not equal. So I'm not going to be able to do this. I'm going to have to... Whereas in some of these cases, I could just rely on Ruby. Here, I'm not going to be able to. So yeah, okay. Sorry, I'm thinking, but I'm not talking. So what I'm thinking is this is mostly going to give the right answer, because this will tell us, because all of those floats are sort of constructed out of structs, we get this equality operation for free. So I think mostly this is going to correctly compare to floats. It's just that it's not going to have any special behavior that might be required for, infinities or nans or whatever. But at the very least, we get the opportunity to implement that when we do it on our implementation of floats. Whereas if it's on Ruby floats, we can't really do anything about the fact that nan and negative nan aren't equal, for example. So I think I'm going to start with this and then use the test to figure out, is this good enough or not? I mean, maybe I'll get lucky and it is indeed good enough. Test CMP. Well, it was good enough for the very first one. Oh, okay. All right. So -0 and +0 are equal, of course. Now what I'm thinking about is, do I want to get into the business of checking the classes of these things? Because what I want to do is say, if both 0, then true, else this. But how do I implement this both 0 thing? Well, I could convert them both to Ruby floats and ask if, and then I can call the 0 method on them, 0 question mark. I mean, it comes back to this, the speculative thing I put in here. Implement nan, 0, etc. So I guess this is a case where I could reduce a use of to float if I made this, if I was calling 0 on both numbers here after converting them to Ruby floats, then if I had 0 question mark implemented on the wasmina float class, I wouldn't need to call to f on it first. Or I could just say, this could be like case left, right in something like that. True. But apart from being a bit of a mouthful, I feel like I really don't want this code to start relying on these specific implementation classes unless it really has to. So I think the fact that it's possible for me to do it in a different way means that I am going to do it in a different way. Left, right, map to float, all 0, which isn't great, but it'll do. That is not how you spell all. What the heck? Oh. This is the wrong kind of Boolean. Okay, let's move this. Let's make this post-processing. Like that. So whatever I return from this conditional gets wrapped up as a bool. Okay, well, turns out, I was going to say there are lots of 0 comparisons, but these are just, this is expected and actual. This test output's really useless. I should just print out green dots. I'm going to do that before the end of this stream. I'm determined to see some green dots. But okay, so that mostly worked. And now what's this? Oh. Expected 0 got 1. Oh. So maybe a nan is never equal. Well, that makes me think that I actually could have used Ruby floats for this then. If I don't need to care about positive versus negative nans, then let's just get this working. Else if left, right, map to float are all nan, then it's false. Oh, this isn't, that's, okay, that's all of the equality ones. So, just for fun, what happens if I push that 2f up there? Yeah. Okay. Yeah, so it turns out I actually didn't need the sign of the nan. I was anticipating something unnecessarily there. Cool. Implement the F32 EQ instruction. Now, one would hope that in a just world, it would be very easy to implement any after this. Not equal, I mean, not any. So I think it's just the opposite. Although I don't know what it will be for nans, but let's try inverting everything and see whether that is indeed what it is. Yes. Okay, well, that was relatively easy. Okay. I'm just thinking about, do I want to combine these somehow? I'm going to leave it for now just because I'm worried that the clarity is going to suffer if I try and there's only two of them. So it feels like the benefits are small in terms of reducing duplication and the risks are large in terms of making this code harder to understand. So I'm going to leave that for now. I can always, maybe next time I'll come back and refactor this away. It seems like I'm in this sort of TikTok rhythm of like, spend the first half of the stream cleaning up my mess from last time and the second half making new mess for next time. So I'm in the making new mess phase of my career at the moment. So this is implement the F32 any instruction. This is literally just the opposite of F32 EQ, but I'm going to defer deduplicating it for now because I'm not confident I'll actually make it clearer by doing that at this early stage. Okay, so next, what was it? LT? Just run the tests. Don't need to speculate about what it is next. Yes, LT. All right, so it's going to look a little bit like EQ. Do I need the special cases though? I don't know. It depends on what the rules are. Let's just start with, like, I don't want to. This is what I'm trying to get away from. Is like that. It's tempting to just sort of reproduce all of this boilerplate, but I don't have any information about whether that's necessary. These are already floats, aren't they? Yeah. So this needs to be less than. Oh. Okay, well then apparently I don't need any of this. I don't know how that works. Maybe Ruby has... Yeah, maybe Ruby just does the right things. You know, a nan is neither less than nor greater than. Why didn't this work with... I'm really confused about why this didn't just work. Do I really need this? Like, it looks like I don't need it. Yeah, what? Is this something that became unnecessary when I switched to... Yeah. Yeah, oh god, okay, I missed that. It's quite subtle. That the reason I needed to check floats in the first place is... the reason I needed Ruby floats in the first place was so that I could check to see if these numbers were nans. But then once you've converted them to Ruby floats, they already do the right thing. And in fact, maybe this already does the right thing. Right, okay. I'm glad I noticed that. I think, yeah, if we go into a Ruby float world, surely this is the same. Yeah. Yeah, the reason why I ended up with this sort of convoluted structure in the first place is because I was trying to use my representation of them, not Ruby's floats. But once I accept that I need to use Ruby's floats because mine don't tell you whether they're a nan or a zero or whatever, suddenly we just get the right behavior. I think I am gonna stick to these. I think I'm just gonna do this. If I'm converting them to floats anyway, you don't want that big conditional, do you? You just want to just let Ruby do the right thing. And then if I do come back and say, well, we don't have to call to float here anymore because I'm going to implement the nan predicate and the zero predicate, that means that we can deal with the special cases explicitly here without converting to Ruby floats, then that's fine. That's great. That's what this reduce the use of 2f is all about. But I'm not doing that yet. I'm just relying entirely on Ruby's floats. So what situation am I in? I'm in a mess. So yes, this is for this. Um, this is for this. Oh, I should have just amended it when it was the most recent one. And then this one is, this is LT. Again, I'm getting a lot of commits for free here. Yeah, in fact, let's make this one a, because did I, oh no. I don't know why it didn't let me edit that commit, because that's what I wanted to do. Because I think now the stuff that I wrote here is not really relevant anymore. I think this paragraph now doesn't make any sense. So I'm just gonna, you know, why am I not deduplicating it? I don't know. Oh look, I totally screwed this up. That's not right. Okay, all right. Where did I? That rebase was a disaster. Okay. Okay. Oh dear. I don't know how I managed to. I think I just, when I was resolving the merge conflict, I just screwed up. Okay, that is correct. Okay. Let's just run the tests. Which is what I should have been doing all the way through that rebase. Okay. All right. Well, I'm going to get some nice free commits here, aren't I? Oh, see, it's wrong. It's wrong. That indentation is not right. Okay. All right. So, Ellie, we're going to get this for free. It's really Ruby that's giving us these, right? What? Oh, well, you also have to, here's a pro tip. When you're copying something to reuse it, you have to change all the bits that aren't the same as where you copied it from. There we go. So this is LE. GT. Why don't I, as a treat, actually change it? Yep. And GE. Nice. Oh, and presumably yes. Error, pending test failed. Pending test passed. So this goes on the end here. So is that right? Nice. So that's cool. I'm glad that. I mean, that's it. That's all of those instructions implemented. Um, it's not even 11 p.m. So there are a few things for me to do now. I could address this duplication, which I think I am going to do because it looks quite easy to do. Then I can try running all of the F64 versions of these tests to see if they work. And then I can have a look at float expressions. Which tests interesting floating point expressions, and I really don't know what is lurking. I mean, this is all about, when we did this for integers, I think it just passed. I can't remember actually, but this is the intention of this file is just to check that you haven't implemented various optimizations. And I'm definitely not going to have implemented any of these optimizations, so it would be nice if this just passed. My only concern is that this is exposing us to lots of new and exotic floats that we haven't seen before. So it might be that there's some stuff in here that we can't handle for some reason. Maybe there's some syntax I haven't implemented, or maybe some of these values are extreme in some other way that we haven't encountered yet. So I don't know. I wouldn't say I'm confident about this. I'm optimistic, but I'm also prepared for this to exercise something for this to stress test the implementation, because it involves, adding and then multiplying, or, this is computing larger floating point expressions than we've looked at so far. So I think I'm going to tidy this up first. Oh yeah, these ones as well. Sort of less of an obvious win. Oh no, yeah, because that's binary and these ones are, yeah, that one's too low hanging fruit. But I think here, if I can do EQ not equal, less than equal, greater than, greater equal, well, yeah. I think if I can consolidate all of those, it's going to make this chunk of code much smaller, isn't it? Again, really the only thing that I'm consolidating here, the only reason I need to do any consolidation is because of all of this ceremony converting the input and the output to be the right type of thing for us to do a straightforward operation on it. And up here, I was able to do that and have the body of these be mostly just a simple operation. And when the operation is not totally simple, I had the implementation of that operation. But as of yet, I don't have the equivalent of with float that is like with float returns bool. And I could write that, but I think if this is the only place I need it, I'm just going to write it in line here. So what this is going to do is convert left and right to floats. And then it's going to, do the operation. And then it's going to, I mean, I guess, and well, obviously what we need to do is convert it to bool. But I'm just thinking, is there an opportunity here to could this literally be something like bool operation.call left and right, and then this actually, this is like decide what operation to do, and as long as it gets a proc back, it can just call that proc with the left and right arguments. That's slightly different to the style of these other things, but in this case I know for sure, whereas in all these other cases there were always asterisks on it, where it's like, well, sometimes it's just a straightforward method call, but other times you have to do a thing. Here we're just literally calling a Ruby method. Like in each case it's double equals or not equals or less than or equal to or whatever. So I think here I can just say, if I just make a mapping, operation is equal to EQ is that. I do want it to be a symbol actually, but maybe that's going to be harder to read. Yeah, I'll do it with strings for now, and then maybe we could come back and change this later. Not equal is going to be this. Less than is going to be this. Less than or equal is going to be this. It doesn't help that the hash rocket here is sort of syntactically very similar to what we're putting in there. I guess there's going to be 6 of these, so maybe I can... greater than is that, and greater than or equal to is that. Fetch operation to sim to proc. Like, if I can get the appropriate string out of here, symbolize it, and then convert it into a proc, then now I can just call it, because symbol to proc lets you just take any symbol and it returns a proc that sends the message with the name of that symbol to the first argument that you provide to the proc. Like, I think this will just work. It's a little bit fussy and clever though, isn't it? Let me see. Well, firstly, let's see if it works. And then secondly, I'll think about whether I actually like it or not. Yes, that does work. Definitely shorter. Feels a little bit smart alecky to me. Well, I think it's not super important. I think I'm gonna let that go for now. Think about whether it's a good or bad idea to use fetch to sim to proc to implement float CMP operations. It may not be a good idea. It feels like this is right on the edge of being too clever for its own good, whereas up here, it's pretty much doing the same thing here, but in a much more straightforwardly visible way. Yeah, okay. Well, I don't really like it actually, but I think I'm gonna let it lie for now. And then, like I say, I can always come back later and change my mind about it, basically. Combine, EQ, NE, what was it, LT, LE, GT, GE implementations. I'm not completely sold on the whole operations in a hash or message selectors in a hash approach, which feels a bit too clever. Well, a bit too, it's not clever, is it? Obscure for its own good. But I'm going to run with it for now and come back later if it starts bothering me. Okay. I think it's right on the edge. I think it's not super obscure, but it's also not the simplest way to write that code, you know. I suppose what I'm doing here really is just trying different approaches to essentially the same problem and trying to figure out if there's one that I like. So I'll give it a chance to bed in. Okay, so let's have a look at those. I don't know why I'm running Vim there. Let's have a look at those 32-bit tests, because there should be 64-bit. There should be an F64, F64 bitwise, F64 comparing. Let's see what happens, apart from waiting. Okay, so far so good. All right. So that all passed. That's great. Cool. Add F64 tests to test script. Well, okay. It was fun. Great. I suppose I'll say in here, well, why don't we be a bit more, which all already pass to test script, because I am slightly surprised by that, but okay. Cool. Well, I've got a choice now of moving on to looking at the float expressions, or doing a little bit with the test runner. I think I really would like, especially waiting for it to finish then. It just made me wish I was looking at something different. So I think I'm going to give myself like maybe half an hour or something, at least a bit of time to improve the test runner experience, because I think that is going to give me the motivation to carry on with these. Well, I suppose I am presupposing that there's going to be some carrying on to do, but I might as well just run float expras here. And because if that works, then I guess we really are done with floats. And I said I was being optimistic about it, so let's actually, oh no, I'm not going to wait for all of that again. Let's just run it. Float expras.wast. Oh dear. Okay. Well, that looks hairy to me, so I'm going to go with my original plan. I'll add this to the pending tests. But that was about FMA. FML more like. FMA is fused multiply add. I'm surprised that's not working. Pending test failed successfully. Right. I'm surprised that's not working. I would expect. I'd be very surprised if it turns out that it's failing for the intended reason. I don't think it's going to be because of anything FMA related. I'll talk about it when we investigate it, but I think it's probably just going to be that I've got a bug somewhere, and that has exposed it. But for now, I will add float expras. What do my commit messages for this file usually look like? Add float expras.wast to test script. Okay. So yes, I'll do a little bit on improving the test runner experience, and then we'll come back and investigate that, because maybe that FMA thing might be something simple. So a couple of things. I think that this output from the test runner is basically useless. Like, it just does a lot of scrolling, but there's nothing interesting in there, apart from, I suppose, in the very early days it was showing me that something basic was working, but at this stage I think we're past the point of needing to see, that two massive integers are equal. We don't need to see it twice. So I think what I'm going to do is just have it print out dots instead. Where are all of the... What am I putting in here? So this is the success. Yeah, Chris says he's surprised I haven't bent my no dependency rules for RSpec. Yeah, it's still on my to-do list to switch to using RSpec. Yeah, I did promise green dots, didn't I? I think it would be okay to... I suppose that's why you said bent my rule. It wouldn't be a runtime dependency, right? It would be a development dependency, but it still feels like... I don't know. I mean, there's something bloody minded about continuing with this ridiculously inconvenient setup that I've got. So, okay, right. So let's see what it looks like if instead of printing out that, I print out a green dot. So I'm going to need to use print, and I'm going to need to use ANSI escape codes, which I know look like this. I can't remember what the color number is for a dot. For green, but then there'll be a dot, and then there'll be another ANSI escape code that is the reset. This should be this, I think. Yes, it's like escape. Yes. By the way, what I'm doing here is ANSI color codes. ANSI escape code. Go away, Jimmy Wales, you rich so-and-so. So yeah, in the terminal, if you send the escape character, which is what \e is, and then an open square bracket, and then a number, and then an M, you can make things be in a color. Okay, so 32 is the point that I'm getting at there. 32. All right, well, at the very least, that's going to print a green dot. There we go. I mean, it's not great, is it? I still think, I think that's already better. Yeah, I find that much more pleasant to look at than that just constant terminal spew that we had before. So that already feels like something of a win. Um, what else do I want to do? I mean, I've got a bunch of. What else am I putting in here? Oh. Oh, because everything else is just arrays, or I think there's a one. All right, well, this can just be a puts. Let's make this. I mean, I'm kind of doing two things at once here. Let's edit this so that this is saying oh, why did I do that? Idiot. Try again. It's frustrating when my brain just goes on like Vim auto Git autopilot and then does something other than what I actually wanted it to do. That's what I wanted to do. So I think this is just, that just is just printing out dots. So let's say print dots instead of expected actual values during successful assertions when assertions pass. Although I guess this is just the ones in the... What is it that happens with the unit tests? Oh, they just don't do anything. Well, let's do that. Let's do that there as well. Float test. It sort of sucks that these are all separate, but whatever. So I'm going to say if actual equals expected, print dot else. Well, for now, I guess. Raise. Well, I mean, that is probably what it's going to do, isn't it? What other unit test do I have? Float test, S expression parser test. Oh no. I don't even have a helper method in this one. Oh, and there's a blank line at the end. If actual equals expected, print dot else that. Oh, that didn't work. I don't feel good about this. Oh, what did I do there? But I don't want to spend any more time in this file than I have to. I think these are probably low value tests as well. But if we're going to do something nice, then let's at least be consistent. Okay. I wasn't proud of that vimming that happened just then. But we have at least got some dots. Okay. Great. So what then did we want to do in here? I am going to go back and change all those dots to green, Chris. You have correctly anticipated what I'm going to do. So what had I done here? Okay. So let's just unstage that and make a commit that's all about the green dots. I think I'll copy this to my clipboard. So in float test, I mean, this isn't so bad, right? Oh, and this one. There we go. And that S expression parser test. Let's hope I can do this. Does that seem likely to work? No. I think I've got to put backslashes in my backslashes. Yes. Okay. All right. I think I'm getting my green dots. Cool. Okay. Make the dots green. I think probably I could do a bit more. Yeah, so here, this is a warning, so I'll do this in yellow. So that's 33. So escape 33M. Escape 0M. So that should show up in yellow. Yeah, there we go. Oh, that should really have a puts before it, shouldn't it? Because it's sort of on its own line rather than part of the green dots. Yeah, that's okay. Actually, I guess these unit tests as well. We should probably just do a sort of cathartic puts at the end. Again, not the neatest solution. Oh, and also the end of the interpreter. How does this work? So hold on. Print a blank line after each suite of tests. Oh, I haven't don't understand what I did there. Because otherwise because the dots are all printed on one line, we need to mark the end of them somehow, which isn't a great explanation of what I'm doing there, but it'll do. Yeah, I think that this is more what I wanted to see. Okay, so I think we're actually getting somewhere here, because this is already much more pleasant to look at. So we've got the colorized warning. What does the failure look like? If I say float expras, right. So I think what I want to see there, so these are the raises. So this one is an actual error. Like, I think what we should do here is put like error and then show the command that errored. And then when we raise the exception, we'll get the stack trace anyway. Oh. Oh, that's an assertion failure. Okay, right, sorry. Okay, well, what do they... Yeah, I got ahead of myself there. What we want an assertion failure to look like. Same deal, I think. In fact, I think part of what I dislike about this, now I didn't realize this until now, but I think one of the things that's antagonizing me is that when it's an assertion failure, it looks like an error because it is an exception and it's got a stack trace and everything. So I think maybe here it'd be nicer if we just exited with an error code. So we need to break out of the green dots, print out the error, and then just stop. So I think maybe this can be like failed. We can show the command that failed. And then we can have this sort of expected value got actual. And then we can exit. So I think that... I mean, that already makes it way clearer to me what's going on. I want to colorize it as well, but just trying to get my head around this first. So this is when there's like an evaluation error. This is also an evaluation error. And this is just an exit. So what have I done? Oh, I've done more than one thing. Okay, as always. So I think everything except that first thing. Oh, those, although I haven't seen them, I guess these also need a puts in front of them because otherwise they'll be mashed up against a dot. And maybe I can be consistent with this, with the one that used to be the warning. Yeah, if I just remove the colors for now. Let's just say warning. Okay. So, sorry, I'm faffing, but bye, Chris. Thanks for coming. So report tidy errors, warnings, and assertion failures in interpreter. And now I'm going to colorize these. So this was warning. How does that look? I think for the warning that's okay. It's quite an inoffensive color. I sort of think for the assertion failure, it's probably going to be enough to have just the word failed in red. Like this. Yeah. Maybe I'll put the body of the command in yellow so that it stands out a bit at least. Yeah, I think that's okay. The red makes it pretty clear that that's an actual failure. And then having that expression colorized, I think makes it easier to pick out. So I suppose these errors should also be red. What was red? 31. And there was another one of those, yeah. So let's just provoke one of those. Well, let's do the I32. Okay, so I can get an assertion failure if I break this implementation. Expected 2 got 0. Okay. If I do something like this, oh, that whole thing is red. Did I make a mistake? Oh, yeah, I put it in the wrong place. I didn't mean for the whole thing to be red. That's too much. That feels punitive. I'm glad I tried it. Okay. That's much better. Oh, I should do the same thing here of colorizing the command. So this is the same as this. It's got a mistake in it. Okay. So yes, that looks good. That's what I want to see. All right, well, I think all of that is... So I'll say add color to errors, warnings, and assertion failures. Well, I can't be bothered to go back and colorize what happens when the unit tests fail. I'm not really expecting to run those. You know, well, I will because they're part of the test script, but it doesn't bother me, so I'm just going to leave those alone. Oh, I know what I could do. I could, for this to do down here, this is just a skipped assertion, right? So I could, here, I could print a yellow dot. And then when we look at the test output, we'll get some sense of, yeah, there are some green, and then there's also some yellow. That's a helpful reminder to me as well that I'm not actually finished implementing these tests, that there are a load of assertions at the end that aren't actually running. Okay, that's good. I like that. Print yellow dots for skipped assertions. So another thing that is stressing me out is the way that these are formatted, because this doesn't actually look like what we see here. And it's got all of the information necessary. In fact, it's pretty much the raw stuff from this S expression. It's just not being assembled correctly. So I think what I'm going to do is all these places where we're just interpolating the command, I think I'm going to put a pretty printer around it. And it'll only take a second to write that. Okay. Oh, I guess I'll do it here. Def pretty print expression. So what do I want to do here? There's only two kinds of thing it can be. It can either be an array of other expressions, in which case I have to put parentheses around it. So this is expressions.map pretty print each one, join them with spaces. I typed the wrong kind of bracket there. I think that's it. Yes. Otherwise, it's just whatever this expression is. I mean, it should already be a string. So maybe that's redundant. Let's see how that looks. Okay, that's way nicer. Not only is it shorter, but it's also got much less syntactic noise. Like that is much easier on the eye. So I'm a fan of that. So what's that? Pretty print commands in interpreter error messages. Okay, well I think that's like a big quality of life update. Let me just see. Let's try. I've spent more time than I intended to on this, so let's just see. I mean the output isn't very nice, is it? Also, this should be red. And ideally... Oh no, this should be green, sorry, and ideally this wouldn't be red, but it would be... We should be able to see green at the bottom there, I think. Let's look at this. So this error pending test passed, that we haven't seen that yet, but that should be in red, and this should be in green. I'm going to use printf rather than echo because it's more portable. In fact, off the top of my head, I don't even know what. Oh, yeah, I don't even know. Well, firstly, I don't know whether this is going to use the built-in or if it's going to use the ancient. All of this shell scripting stuff on Mac OS is a total disaster, so I'm just going to go with something that I know is going to work. This is so that I can do these escape sequences. That's what I'm worried about. So what, 31 and 32? Was that right? Oh, I've lost my... Yes, 32. 32. E bracket 0M. Okay, well, I'll let that run. So the other obvious thing is that I think that although seeing the output, so that set minus X, so that it sort of echoes everything that the shell script is doing. There we go. Oh, I need the printf doesn't include a new line. That was good to get things started, but I think now it's not very nice output. So I think what I will do instead is print it ourselves, but let me do this first. Add color to a test script, or pending test, success, failure messages. And then I think what I'm going to do is get rid of the X here. So now it's just going to be like an anonymous green dots. And I guess before each of these, just trying to think what I want to show. Maybe just the file name that's being executed. Like if I take this and I just print it out. So if I just printf Could I do it in bold or something? Yeah, 1 bold or increased intensity. So if I just print the file name in bold, so oh, this is printf, so I need to, well, I don't need to, but I should interpolate it. And then reset, then colon, then like that, and then all the dots will appear after it. So here, this is going to be script dot. Oh, I forgot that. I think that's the done thing. And then for, I should have pulled this out. And then for pending, there's really no reason for all of these to have different names. Maybe here I should say pending. Okay, let's have a look. Yeah, I really like that. Oh, that makes it so much more pleasant to look at. Yeah, the long wait is annoying, but okay, great. All right, that is a massive improvement. So what do I want to do? What did I do? Turn off -x in test script and print our own information instead. No, I don't have anything else to say about that. Okay, I'm pretty happy with that. I mean, the only... just thinking about whether I want to get into this now. How difficult is it going to be? I think the answer is not difficult. I'm thinking about just making the parser incremental. Is that going to be hard? I think if I'm lucky, it's actually going to be really easy. I think that should be easy. Let's give it a go. If it turns into a nightmare, then I won't do it. So the way this all fits together is that the interpreter calls sExpression parser.parse, and it gets back an sExpression, and then it just calls each on it. So in theory, well, let's see. Okay. Okay, so I might have to do this in 2 pieces. But firstly, I can make this return an enumerator, and it won't know any different. Because it just calls each on it anyway. Oh, sorry, I'll close all these irrelevant things. Yeah, so because it's only calling each on it, here I can just do this. I can just do this normal idiom of, I can say return, convert this method to an enumerator with the argument unless block given. So what that'll do is the way this is being called right now with no block is going to trigger this line, and then toEnumerator is just going to return an enumerator that's wrapping this method. And what the enumerator does is provide a block to this method that we can yield results to. So just thinking about what we want to do here. Yes. So what I would do is this method gets called with a block. So now instead of returning the expressions, what we do is we iterate over them and yield them. And I think that should just work. Expression parser test. Maybe this is going to be too fiddly. It's a shame because presumably yeah, so the interpreter's okay with it, but just not the unit test. Can I be bothered to fix that up? I am not sure. I wonder what happens if because I could do it. Let me just stash this for a minute. I could do this change inside parse expressions. That's fine because this is the only place that gets called. Like if parse expressions here returned an enumerator, then I could just call entries on it here and the unit test would be none the wiser. So maybe I'll do this, at the very least, I'll do this maneuver inside here, and then at least I've got a bit closer towards making it incremental. So I can say this method, if it's called without a block, turn it into an enumerator. Yeah, and then this is sort of more naturally suited because this accumulates an array. So rather than accumulating that array, this can just be a yield. And then I think that'll just wow. That was a big error message. What's it not happy about? couldn't match close bracket in the entire expression. Well, let's try it on something slightly. Okay, well, that's also massive. So what have I done wrong? Why can't I just do that? Oh. Maybe this isn't the only caller of it. Oh. Oh yeah, of course. This does need to be called recursively. Okay, fair enough. Okay, that really is all of the callers. Okay. Well, that's not exactly what I wanted, but it's better than nothing. I mean, it's not actually achieving what I want yet, but it means that that part of the parser is now successively yielding expressions. Oh, maybe that does give me what I want. And then this is like so that we can try to make parse return 1. Okay. So is it worth I think I'm going to give this a try. I know I already did it before. But this is going to need to be slightly different because now that block that we get, so we're going to do the same thing here, 2enum of the current method with the string, unless we're given a block. And then we remember the string. We don't need to remember this anymore because instead of returning parse expressions, we are going to call it with the block we were given. That seems like it should work. So you see, it does work, and it feels like the test is starting to run way faster, even though it's not really. Yeah, but the unit test doesn't like it. I don't know what to do about that because I don't really care. I suppose what I'm going to do is that. So it feels like there's much less waiting now because it can immediately start iterating over those expressions and they're being parsed as it iterates. Yeah, I mean, I like that a lot more. Oh, wow. I've spent too long on this test runner, but it was really bothering me. Okay. What do I want to say about this? I feel like this does require some kind of explanation. This means that the interpreter can start receiving expressions straight away by calling each on the result of parse, instead of waiting for a complete array of all expressions. So tests will start running sooner, which feels more responsive, even though the total amount of work and thus total runtime is the same. So again, that's really just a developer experience consideration, but given that I am the developer, I care about my experience. Oh God, this feels so much nicer. Why didn't I do this weeks ago? I really like this. Okay, great. Okay, let's have a quick look at this, because I don't want to leave it with this sort of weird failing test. So this make S expression parse incrementals test start running. I think I've done these. Colorize test output, reduce test script noise. So all of those things that I was upset about are now dealt with. Okay, let's do a targeted hit on this. So the one that's failing, I can now see, is this very nice F64 no FMA. Oh, these are at the top. Which is, I don't know why I'm saying that in a happy voice. It means that we haven't got very far into this file. A799p plus 52. So yeah, it's this one. So all of these are passing, and then just this last one is failing, which again to me suggests that it's not an FMA related problem. So FMA is fused multiply add. This is an instruction or set of instructions that the CPU might have that allows it to do some form of multiplication and addition all in a single operation without rounding in the middle. So what's this doing? So this does multiply x by y, and then it adds z. So if we had, if our interpreter was clever enough, which it certainly isn't, to know about the fact that there might be a machine instruction that is able to do multiply two floating point numbers together and then add the result without doing an intermediate rounding, so without rounding the result of x plus y and losing precision before you add z onto it, because you don't actually need to do the final rounding until you re-express this number as an IEEE 754 float, right? So if your machine has an instruction, which I think mine does, FM add, yes. So my, I'm on a Apple Silicon machine right now, and I'm pretty sure that this is the instruction set that my machine uses. So it does have this fuse multiply add instruction. So yeah, if you were using a compiler or an interpreter that knew about that instruction, it might be able to get away with doing this in a single CPU instruction. I'm definitely not trying to do that. That's why I was a little bit confused when I saw that this no FMA test was failing. Test that x times y plus z is not folded to FMA. I am definitely not folding anything to generate a fuse multiply add instruction. That is not yet a feature I've implemented. I'm not even going to put it on my to-do list. So I'm confused about what's going on there. Expected this big number, got this big number. This looks like basically the same number to me, but this one ends in 29 and this one ends in 30. So that's immediately suspicious to me. I mean, slightly worryingly, I guess that's all that this can be testing. This must be detecting whether these numbers must be chosen to provoke this optimization, such that if you don't round in the middle, then you get a different answer at the end. It must be designed for for the result of this multiplication to get rounded up, so that when you add something else onto it, the final result is one higher than it would otherwise be without that intermediate rounding. That would be my assumption here. And this has failed in the way that the result is one larger than it's supposed to be. But I'm not... Hold on. So this is actually failing in the opposite direction, right? If somehow I was accidentally, or if MRI, if YARV was able to do this fuse multiply add optimization, then I think the result would be 1 too small, but the result here is 1 too large. So this doesn't even smell like this test has detected the problem it's supposed to be detecting. I think this is just a different problem. Well, maybe I'll try doing this. I'll try doing this on the console and see what happens. So this is X. So X is wasmina float parse this. Y is this. And Z is X, Y, Z. So those are all just big rational numbers. Oh, but interestingly, this one is an integer. Oh, maybe they all are. So how? Oh, I guess this is, yeah, my sort of naive thought I had there was like, well, then how could they ever be rounded? But of course, it's not the number itself that gets rounded, it's the quotient that gets rounded. So if you've got a large enough integer such that it can't be directly expressed as a float, because as you get up to the very large floats, not every integer is expressible. There are gaps between the integers, in which case there is some rounding. So I guess, I mean, these numbers look pretty big. That's, yeah, 2 to the 52, 2 to the 685, and then minus 2 to the power of 690. So those are pretty huge numbers. So I can believe that that would provoke the rounding behavior. So what are these fractions? What are these? That's base 16, right? Because my expectation is that each of these fractions is just the rational, that just the denominator of their respective rational, right? I mean, I'm not I'm not even really debugging anything here. I'm just confirming that my understanding of what's going on here is correct. I think these are just three big integers, and the rationals that we've got here, like all that my code has done is like decode the hex notation and then whack it into a rational with a denominator of 1. 1C7, yeah. What am I doing to S? To I is what I want. That's negative, but I can just remember that's negative. To I 16. And then I want to, well, I don't know what I want to do. Why is this? I don't understand why that is so huge. I guess that's multiplied by 2 to the power of whatever. Oh right, because this one 6 7 2 3 2 5 6 9 8 5 3 6 4 3 7 7. Right. So because this one's times 2 to the power of 52, which is 13 hexadecimal digits, which I guess is those. Yeah. So this one just becomes the times 2 to the power of 52 just moves the decimal point all the way to the end of this one. So that's just, it's just literally that number without the decimal point in. These other two are multiplied by a huge exponent. So this one, the numerator of this one should be equal to this multiplied by 2 to the power of 685 minus 52. I think. Yeah, that's the same. And this one, similar deal. So this one's multiplied by 690 minus. Okay, and that's Z rational numerator. Yeah, that all looks okay, doesn't it? At least I've understood these numbers properly. Oh, hold on. These... Hold on, have I got these in the right... Yes. Sorry, I was just confused. I thought I had them in the wrong order. So this is supposed to be that's why I was confused, because there was another one, but this is the result. expected. So does this... Okay, so this too is just a huge fraction, or a huge integer, sorry. And this one, again, it's going to be this. So that number times 2 to the power of now 738 minus 52. Yep. Okay, so what's the problem here? X times y plus z. Oh yeah. X, well, X to float. 6.72. Okay. Okay, that's the answer. And then we encode this back again. Hold on. From float. And then expected. Well, that's the right answer. Hold on, what's going on here? All of this parsing was, I think, like everything about this checks out. Like this all seems to be correct. All of these values are what I was expecting to see. So that's all okay. If I convert these, I get the same number, 1.919, blah, 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 286. Expected to float, 1919, blah, 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 286. That's fine. Let me round trip these. So what if I say, I'm just trying to think different ways of interrogating this encoding. What if I, like for each of these numbers, I can, because it's not, at this point I haven't actually encoded it. I've just stored it. So I can encode it. Like I've stored it as a rational, and then I can encode it and then decode it, and that's fine. So it's round tripping through the encoding, okay. Right. problem is I feel like I'm sort of checking my own homework here because I'm using the parser to parse these in the first place. Maybe if I get Ruby... Ruby can't parse this. Ruby can't parse this. What I could do... Yes. What I could do is get Ruby to sort of... I could ask Ruby to evaluate this. So I know that the value of this and it just is that, isn't it? Hold on. I'm a bit out of ideas here. Okay. It's a little bit difficult to get my head around all of the different permutations of what's going on here. So I've got each of my numbers. So the only thing I'm not directly testing here is that I don't know what 64-bit integer this is being encoded as, because this is just round tripping it through pack and unpack. So maybe if I say double, so now I can encode X. Format. Okay, so I'm just trying to think what happens in the implementation. We parse the float. Yeah, that's what I'm doing here. We parse the float. We encode it. And then that's what gets... I mean, it actually doesn't get stored anywhere, but that's the value of this expression that gets returned. So it's been sort of serialized down as an integer. And that's going to be true for all three of these. And then each of those integers gets like rehydrated back into a... On its journey to becoming a float, we get sort of decoded X equals X.decode. Do I have to give it a format? Oh, this is just a number. It's wasmina float decode encoded X format. Ah! That's not right. So it's not even to do with... It's not even a problem with the multiplication. It's just a problem with the... encoding and decoding. What on earth has happened here? because this is just an integer. So hold on. From integer, that, if I encode that as a 64-bit float, and then I decode it to I. Oh. It's just a numerator of this rational. I get a different number. Three 378. And I mean, I said earlier that I'm expecting this to be designed to provoke this kind of, oh, integers so large that they get rounded behavior. But I don't think this first one is large enough. That doesn't feel big enough to me. I think these ones are large enough that I would expect there to be like a rounding error when we multiply them. But if this, it wouldn't make sense if this integer on its own was large enough to be rounded, because then, well, no, you can just see that it isn't, because these are the bits written out. That's the whole point of this notation. So I mean, I might be wrong about this, but my intuition is that it's not possible to write a float in this format that where this legitimately happens. I think that it's just not encoding it properly. Well, okay, so that's something that I can test, right? Well, I don't know. No, this is the right value, right? Because the value of it is this. So I can just say the number is supposed to be, well, I don't know why I keep doing that. It's a string thing. I can just write it down. Okay, so that is the legit number. Let's find out what that should be. So if I pack that as a float, oh, a double it should be, and then unpack it as a quite long number, unpack 1, it should be 484 blah 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 081. And when I actually did it up here, it was 484 blah 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 082. So that is just wrong. So I'll make a unit test from that. It's like a regression test. God, this is... I didn't realize this was going to be quite so gnarly. Does this work if I just... Yeah. Okay. So let's say integer equals this. Encoded equals, encoded by Ruby is this. I need the format. Format equals wasminer float format double. So this is encoded by wasminer. If, well, actually, let's call this expected. actual, and then I can just copy this. Not very beautiful. So now, okay. Yeah, I didn't do the work to make this. How does it work in? Failed. Expected blah, got blah. I mean, while I'm in here, I might as well make this do the right thing. Failed. Well, there's no command. Was minna float encode, I suppose. Expected got okay. Well, I don't really want to commit this because I don't want to commit with a failing test, but so what's going wrong here? Like, I feel better that I've got a failing test. So rational is rational. So format is double. X equals parse that float. And then I just want to encode it. Rational is 6723 blah 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 377 over 1, significand 378. So it's in here that it's gone wrong. Inside approximate within. Approximation new fit within. So let's see this. No, that's not right. It's the numerator and the denominator that get updated inside here. And that seems suspicious to me. So let's say before, during, after. Okay, this is where it goes wrong. After. Okay, well, I mean, I guess this is obvious. It's the rounding that's the problem. Rational is blah divided by 1. Quotient is that. Remainder is 0. So why does it get rounded up? If remainder is greater than denominator divided by 2, which it isn't, it's 0, or remainder equals denominator divided by 2. Oh, okay. Shit. Well, so not a lot of people know this, but you don't need to do any rounding if the denominator is 1. Like, what's happening here is that the remainder is 0, but that is half of the denominator. 1 divided by 2 is 0 when we're restricted to integers. So it's triggering this case where... So this is going to be true for any odd number. Any odd integer. Can that be right? Like 5. Oh no, because it's been scaled up. Right, so this is actually quite... For this to happen, it needs to not just be an odd number. It needs to be an odd number that doesn't get scaled at all, so that the rational, that the numerator and the denominator that makes it into this part of the program, the denominator is still 1. If a number's been scaled up, then it's been multiplied by some power of 2, so it's obviously going to be even. If it's been scaled down, then the denominator has been doubled some number of times, so that is also not going to... It's not going to be 1. So for it to be in this special situation, we need to have a number, an odd number that is already 53 bits long. Oh, well, this is rather hard to... I mean, I suppose I should just enter a 52-bit number. 53-bit number. I'm just guessing how long that is. Okay, that's too long. Oh, close. Okay, so that's a 53-bit number. So if I parse that, I do get the right number. And if I encode it, it gets rounded up. Because that line of code is not correct. Like, well, it is correct as far as it goes, but this only makes sense if the denominator isn't 1, or equivalently, if the remainder isn't 0. I mean, I think the latter makes more sense. It's like, if the remainder is 0, then you don't need to worry about whether the denominator is 1 or not. Like, if the remainder's 0, then the quotient is perfectly accurate. And if we've got a perfectly accurate quotient, then we never need to think about rounding. I mean, obviously, the intent of this line of code was that the remainder is always going to be greater than 0, but I just didn't think about this special case when we've managed to make it to this point with a denominator that is still 1. And then crucially, this division by 2 in the denominator is what kills us, because the remainder will be equal to the denominator divided by 2. And then if the quotient is an odd number, i.e. if the original number was odd, then we get 1 added to it, which is not at all correct. So this has been a very long-winded way of saying that I think here we should say return if remainder is 0. What else did I do in this file? Oh, it's just puts. Well, I mean, this is quite... again, I'm being quite optimistic removing these, but I know that I can undo it. Is that what I want? Yeah, I think that's more meaningful. Even though I could avoid this division if I just said return if denominator equals 1, I would rather not. I know that's sort of. I was going to say I'd rather avoid a magic number. I know they're both kind of magic numbers, but I feel like this makes more sense. That if there's no remainder, then you don't need to do any rounding, because the quotient you've got is bang on. Don't round it. And then the fact that this covers that, well, this is the only case where it matters, because any other case is going to be caught by this conditional, which I guess is how we managed to get this far in without this being a problem, is that this is apparently the first time we've ever been given a number that is both odd and of the correct magnitude to trigger this bug. So I guess we've just never had an odd number with P52 on the end before. I mean, that was a very silly oversight on my part, but, well, it was just a silly oversight. But I'm also not surprised that I didn't think of this problem. Like, it's... To me, that is not obvious. Okay, so let's... float test. Oh. Okay, so... okay, a different problem. But... this is the important thing. So let's say something like, don't round quotients whose remainder is 0. And I can put this in. This was the cause of a nasty bug when we encoded a float like blah, whose magnitude is in the right range to not get scaled up or down during encoding. The rounding procedure was adding 1 to the quotient because the number is odd. That's clearly wrong in the case of an integer, i.e. a rational with a denominator of 1. The fix is to avoid rounding integers, and the most the remainder is 0 feels like the most appropriate way of characterizing that situation to me versus, e.g., the denominator is 1. Which would also fix the bug, but feels more disconnected from the source of the problem. I'm not sure I've explained that very well. What have I missed? When we encoded a float like blah, whose magnitudes and right range not get scaled up, the random procedure was adding 1 to the quotient because the number is odd. And rounds to even is triggered by the remainder, in this case 0, being greater or being equal to half of the denominator, in this case also 0, because 1 divided by 2 equals 0. Performing any rounding at all is clearly wrong in the case of an integer, i.e. irrational with a denominator of 1. Yeah, I think that, I mean, that'll have to do. I'm getting pretty sleepy. I might have another few minutes of life left in me. Does my laptop still have life in it? Yeah, it seems to. So what was that final? I feel like I just want to poke this one last time, because this looks like, it says length mismatch. Can't actually see where this problem is. No matching pattern error. Oh, so this is actually happening. I was confused because I was like, all of these are in a rescue, but it's actually happening at the top here. Inside interpret, not inside evaluate. Because it's found something for which we don't have a pattern match at this level. I think this begin rescue end stuff should actually be around the whole. Should be around this whole case statement. Yeah, it should be, because we found 2 places where exceptions might happen. Well, they're both inside calls to evaluate. But there are other exceptions that can happen inside here, like other methods we call might go wrong, and in this case the pattern match has gone wrong. So I'm just gonna, what I'm gonna do is lift this out. Let me just stash it up here for now. Because it could go around the whole thing and there'd be no problem with that. So this one just needs to be expected value equals. And then we just have to do the indentation right. Oh, I think my laptop is struggling a bit. So this whole thing goes within begin, rescue end. So the command here will still be, that's still in scope. We're still in the right place to be able to report the command. But now any kind of failure inside here. The reason I'm doing all this is because that didn't tell me. What I want to know is what was it trying to execute, and without an error message I can't tell. Okay, look, now I can see. Okay, so that's a useful change in and of itself. Lift error reporting around entire well, let's say around top level of interpret. This way we get good error messages. Well, let's not go that far. Better error messages for anything that goes wrong during interpret, e.g. a pattern match failure, not just when calling the evaluate method. I had to do that so that I didn't get a octothorpe at the beginning of my line. Okay, so what actually is the problem? I'm going to give myself 10 minutes and then I'm going to give up on this. So here, oh, this parameter hasn't got a name. You see, normally this would be like local.get $x, like here. Param dollar something type, local get dollar whatever. But apparently you can also just refer to them by index. So this is just get the 0th one. I mean, I assume that's what it's doing. I think that's a reasonable assumption. So I guess it's this pattern match that's failing. Yes, line 32. Yes. So if instead of just forcing it to be in this form, I can say case parameter. So if there is a name, then return a parameter with a name. If there's no name, and it's just a type, then I guess we just, I mean, these are optional. Like we can do that. Ah, yes, fetch key not found 0. Okay, so it's trying to find a local, a parameter. These turn into locals, right? Like the parameter names get zipped up with the parameter values down here, the argument values, I'm sorry. So that local.get instruction is trying to find a local whose name is the string 0, but that's not going to work. So in here, let's say if name start with $, because I think that so parametric instructions. Wow, my CPU is really struggling here. I don't know why. It must be the math jacks. So this local.get, local index. Indices can be given in either raw numeric form or as symbolic identifiers. So raw numeric form is just a number. Symbolic identifiers is this ID thing. Identifiers symbolic identifiers, the standard lieu of indices start with $. So that's all I wanted to know. I think this is correct, that if it starts with $, then I can fetch it from the hash. Else, locals.values.slice name to integer. Like, forget the fact that these are stored in a hash and just pull out the values from the hash and then retrieve the nth one where this name has been turned into n as a number, a base 10 number. Oh, memory. Okay, well, I don't know what that is. Okay, look. That'll do. What is this? Add support for numeric or, unnamed function parameters. These can be retrieved by index rather than ID. And I shouldn't have closed that window because I'll say identifier. Cool. All right. Well, let's run the... I almost did a get push there, but I haven't done this for a while, so let's just let this run. Wow. Great. Wow, I'm really enjoying this new runner. This I know it's the same as the old one, but it just feels really good. So I'm enjoying that a lot. All right. Well, we'll just see these tests pass, hopefully, on GitHub, and then I can go to bed because I'm very tired. Oh, look at that. I mean, I suppose I knew that GitHub would... I knew that it had support for ANSI colors, but it's nice to see that. Oh, there's some white dots there. Why are there white dots? That's a problem for another day. I don't think we had... Where? Okay, I'm at least a little curious. Oh, okay, well... GitHub never change. Oh, that's the wrong thing. Okay, well, I'm not that interested. Okay, look. I think it's time to say bye. But we got to a good place. That expression literals thing is not fully working. But the reason it's not fully working is because it's using a feature we haven't even looked at yet, which is integers. Not integers, memories. We have looked at integers. So that's exciting because that means that I have at least a sort of plausible deniability about the fact that I'm sort of done with floats and that I can move on to something else. So next time, I suppose I'll look at memory. Like, it looks like memory is the next thing I'm going to need to get working in order for that float expressions file to work. And that sounds great because it's not just numbers. It's like a slightly more interesting part of the WebAssembly spec. So yeah, that's what I'll do next time. Um, I'm sorry, this has been very long and probably quite a boring one. But you know, I've just got to keep going until this is all over. So if you are watching this, which you are, because you're hearing me say this, thanks. Thank you for sticking with it. I'll see you for the next one. Bye bye.